Hello, hello. And we're back for more Advent Code. Today's day 7. Oh, okay. So we just do we just start immediately or do we wait a little bit? Because I was working on the language yesterday. I was fixing the memory leak. And I didn't do it on stream, but I found the bug off stream. And it actually made the language server really fast. So we can actually work with the language now without waiting for 10 seconds after every character I type. So that's good. But then all of the yeah, I guess it's all of them, right? All of the previous days stopped working because I have been changing things. So let's maybe fix the bugs in the previous days first. So there is no anymore the string to int32 function. Instead, we just do parse function. We just parses the string generically for anything that implements the from string trait. So all of these should just be parse. Makes it a lot easier. Int64 to string is the other way. This is just to string. Another generic thing. Int32 to string is also just to string. And then over here, string to int3064. This is parse. And then the last errors that we have is that we have duplicate syntax. So I moved the syntax as into the language with this parse thing. Is we'll assume you want int64, not int32. No, it is going to determine which type I want based on the type inference. Similarly to Rust or I don't know, any language like well, I mean not any language, right? Similarly to Rust, and Haskell can do that too, I guess, right? Through traits and type class stuff. Right? So basically we have the function parse. This function is taking string and returns t, right? So if I say that x is of type int32, then it's going to parse it as int32, and if it is int64, then it's going to parse it as int64. If I'm going to say that this is a float, then it's going to parse it as a float, right? So it depends on what the type I assign the result of the function to, because that's what the function returns, right? So if we know what the function should return, then we know what the function should parse, right? That's how the type inference works. It doesn't work like that in languages with different inference algorithm like C++ or Zig, right? Where you must know the type of the inputs to the function, and you cannot infer based on the output of the function, right? But we can do that. Swift is similar. Yeah. Can you do that in Swift, actually? I thought Swift have the different Swift inference. Swift type inference. I'm not sure how it works. Statically type the type of each property, declared at compile time. It infers generics based on the return type. I mean, you can say that C++ also infers generics, but it's not always doing that. Let's see, Swift parse. string to int 32. You'd have parse t string and do that. Let x int is parse. What if I don't say that x is of type int? Yeah, and then later I use x. So like, let's say that I say let x be parse 1 to 3, right? I don't specify the type. So what's the type of x in this case? It's not inferred, right? But what if I use the x later in a function that uses an int32? So like I have another function which uses something of type int32, right? And it returns nothing, right? And then I try to call this function using argument x. In this case, because I called this function which takes an int32, that means that x must be of type int32, and that comes to the conclusion that parse should parse an int32, right? So does Swift do that? I don't know. I mean, it might, but I'm not sure. Because I was assuming that it's more like the C++ style inference. So maybe like it can do it because the type is written in the in syntax, right? So when you assign the result of the function to the thing for which you know the type, but you know the type syntactically, like, you know, it's a little bit different than inferring like that, you know. All right, so what do I want to do for this one? It's interesting. What's the use case for this? How often it's used? I cannot remember any situation when you needed this. It's used all the time, in my opinion. Like, I'm not even like thinking about that. Like, for example, let's see over here. Let's see somewhere in my advent of code here, right? I'm pretty sure. Like over here, see, I'm creating a list, right? So in this case, I'm creating a list. What's the type of the list that I'm creating? Well, in this case, I'm specifying this, but this should be inferable too, which, like, I can just do that and it will still be inferred. I have like anonymous types right now, which is why it's not saying that it's a problem, but like it's automatically inferred that it's the list of problems here. So the type of the list here, this is also a generic function, right? I don't need to specify that this is creating the list of problems. This thing is being inferred, right? I don't know, it is used all the time, in my opinion, when I'm writing Rust code, for example. I mean, yes, you don't necessarily need it because you can always be explicit, but like, why not just let the inference do the job? It only works if you have do stuff int and do stuff parse in 32, not inferring otherwise. Yeah. So being explicit is also not always even possible. So sometimes the only way to write code is to rely on inference, at least like in language like Rust, where some types are like Voldemort types, where you cannot name them. For example, when you create a closure in Rust, right? So what's the type of the function, right? This over here, int32 as int64. This right now is a function that takes an int32, returns int64, right? But in Rust, every closure, every function has its own type, so that we can monomorphize and do a generic and do like more efficient code generation, you know. Because otherwise, if we just have the function which is a point, that's going to be like going through another interaction, which hurts performance, right? Swift has huge problem already with compile times, with how they did type inference. So I'm glad Stockholm Syndrome, they don't try to be too smart. Yeah. Yo, Zombie Cho. Hello. Thanks for the raid. Question marks? The Doctor Professor? What's the question? Hold on, Zombie Cho.
Raid.
We're back. Bad Cop has a sword. Yes, be careful everyone with what you say, but welcome raiders. So you guys were doing the Advent of Code, and you are here for the Advent of Code. I did not even start reading the problem description yet. I was just fixing my previous days because I updated the language. So I'm solving the Advent of Code in my own language, and my previous days stopped compiling because of the changes that I did. We Advent of Coded. You got tracked by part 2. Wait, did you not solve it? As soon as you turned off the stream, you figured it out? I see. Yeah. We'll see if I have trouble with it. Let me just fix this real quickly. So, like, basically, I moved the syntax as into the language. So it now means that I have duplicate syntax rules. So I think, let's call this as2 for now, you know, as2. Actually, you know what? Let's call this as in 64, because that's what I'm doing here. As in 64. Yeah, let's do that. As in 64. How about that? As in 64. So as in 64 is going to be replaced with as in 64, which is kind of wrong, but it's okay. And string to int32, so this is going to be to string value and then parse. That's how we convert an int32 into an int64. We convert it to string and then back for now. You know, it's a little cursed, but you know, it's going to work at least. And then we do the same thing for day 5. This is actually like duplicated over here. Seems fine. Yeah, that's how you convert your integers between the types too, right? Okay, what is this? No recursive imports. I feel like this is a bug though. This is the... What if I restart my language server? Then I don't have an issue anymore. Okay, that was a maybe some problem. All right, let me just check that day 6 is still working. It seems like it is. This is part 1. Let me check day 6. What was the example for the input? What is the answer for the input? 4277556, right? So this is still correct. Okay, so I fixed it. Let's now get to actually solving the day 7. Fixed old code. A bit of JavaScript. Var copy JSON parse JSON stringify. Yeah. Is as2 better than as? I just cannot use the as because I already have the syntax as because I moved it into the language, but it's used for like for traits. I want like an as6 and 64 actually work, but I need a little bit more work on that. All right, let's just read the day 7. Let's get to it. What do we do? Magic smoke. All right. All right, we don't really read the lore here, but what is this? So we have a triangle of sorts. Let's do day 7. Input txt. Add day 7 to the workspace. There you go. A tachyon beam enters the manifold at the location marked as. The tachyon beams always downwards. The tachyon beam passes freely through the empty space. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam. How do you pronounce this name? What does this even mean? hypothetical particle that always travels faster than speed of light. That's impossible, right? Beam continues from the immediate left and from the immediate right of the splitter. Okay, that makes sense. That makes sense. And in this example, the examping tachyon beam extends downwards and reaches the splitter. At that point, the original beam stops and 2 new beams are emitted from the splitter. Those beams continue downward. This process. To repair the teleporter, you first need to understand the beam splitting properties. In this example, the tachyon beam is split into a total of 21 times. So if the beam is split into the 2 beams, and then they are like, do they get unified? This says 21 time, right? But this is not 21 in the bottom. Okay, makes sense. So we just literally need to calculate the total amount of splits. Tachyons travel backwards in time and the paradoxes cancel out. Okay, so I mean, this is a really easy one, right? We just basically we can do it with dynamic programming to do it efficiently. We go bottom to the top, and we for every cell calculate the if the beam starts there, then how many times it will be splitted totally, and then that's all. Split 21 times is 1, 2, 8, 16, 34. Advent of code to be renamed. Right, toy parsers calendar. I don't know. A lot of people are. I mean, how many people are doing their own languages for the advent of code? I feel like most people are still just solving it in existing language, right? Or trying to learn a new language, or trying to be masochists like Bad Cop and do it in some weird way like Bash or SED or whatever, right? Okay, let's read the input first, right? So we just do, I mean, we just have string lines of the input, and how do I do this? I'm just going to store the list of lines, right? So so map is like the list of lines, list pushback map line, just like that, you know. You're trying Janet this year. What's Janet? Is a programming language? Janet, line. So Janet's a streamer. Oh, it's a programming language. I see. Janet is a good language. Nice, nice, nice. Of course it's good. My language is also good. Look at this. So we have made a list of strings. Next, we just go bottom to top, right? And we calculate the things. Let's copy the code to solve today's advent of code in Bash. Yeah. She didn't solve though the part 2, as I understand it, right? Might try cast next year. Always looking for the new language. Yeah, maybe like next year it's going to be even better, but like, I mean, this starts to actually feel like a proper programming language, right? I fixed the LSP yesterday. So like yesterday when I was solving advent of code, after every change, I needed to wait for like 10 seconds before I had like the response from the LSP, but now it's almost instant. So like I fixed a bug, and it's really nice. The LSP is now blazingly fast, yes. I just need to fix my auto-completion, I feel like, is like one of the missing things. Like I cannot do std dot and then like see what's inside std, for example. But I can like hover on the STD and then it will tell me what's inside. So Python is faster than Rust now. Wait, why Python? My language is not written in Python. Insert STD joke here. I saw you running LSP through Python. No, this is I did an LSP stress test. So like I was yesterday off stream trying to stress test my LSP to find the bug, right? So this is like this was like a simple thing. Yeah, I still have like the this thing running to see what's wrong. It's like a simple script. The language is written in OCaml. But I just did a simple stress test, which does like the fake requests to the language server. So I'm like opening a file and like doing a bunch of dummy changes in a file in a loop, so that you know, so that I don't need to test it manually, the LSP. That's all. Hopefully you also read LSP calming and relaxing. Yeah. How many GPU you have? Here's my NeoFetch. How many GPU? How many GPU? How many GPUs? I mean, I only have one GPU, I guess. I don't even have the integrated one. So only this one. 5700 XT AMD, which has 8 gigs of RAM. Why are you asking? I'm not like using it to run an LLM locally. So I'm barely using my GPU. You are not in the data center in Arizona. Does it even count as programming? Yeah, okay, let's get to the Advent of Code stuff. So yeah, like I said, we're just going to calculate for every position. Or I guess not. I don't need to count for every position. All I need is to know for the previous row. That's all, right? So we are going to have, you know, previous row, answers. Or I guess like next row answers, because we are going from the bottom to the top. Is start always at the top? I'm assuming it's always at the top, even if I get the actual puzzle input. Yeah, the S is always at the top. Let's save this as day 7 input txt. Wait, what? It already exists? Oh, this one must be example. There we go. So it's always at the top, right? So we start at the bottom row, and originally we know that the next row, which is like below the bottom of the input, is just going to have an answer being 0, right? So we just say list create, and then we say for I in 0 to n, we just say that we push back next row answers 0, like this. I just need to like say that n is the length of map. I don't have methods yet, so we need to do like this. List at map 0. So this is the string, and then we get the length of it. Like so, right? List at. Type check fails. String is not. Okay, yeah. We need parentheses here. There we go. So n is the number of character in each line. Maybe this should be called m, right? And then n is the length of the map itself. I would guess a splitter can be missed, right? Otherwise, you just need line before last. Or am I missing something? Yeah, the splitter can be missed. But if it's missing, then it means that 0 splits are happening, right? So we know that there is no splitters below the lowest line, which means that the answers originally is 0 splits for every position, right? So because there is no splitters below the last line. right? I mean, it seems like in this specific example, the last line already has 0 splits. So like, yeah, they're being a little bit nice for me. So there's no splitters in the bottom line. Yeah. But yeah, we just do this. And then, so one thing that I don't have is the down to. This is a special syntax for now. So I want to go the other way here. We want to go for I in like reversed from like, this must be M, by the way. This must be M, and this must be like N to 0, right? I feel like I want like, let's do a separate syntax for this. But what should it look like? What should it look like? So like in Rust, it looks like 0 to n dot rev. For example, in some languages like n down to 0. What's the good syntax for this? We can just do a function like in Python, and 0 minus 1 or whatever. Although I cannot do a function right now because we don't have iterators yet. This is fake. Let's start with down to. Maybe I will change it. So we will define a different syntax for reversed, for range reversed or something. Reverse. But you say reverse dot dot dot. Wait. Oh, and dot 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 0. I mean, I use double dots here, but like, I mean, I think it's not really clear. No. Haskell style and n minus 1 dot dot 0. I don't know. I don't like that either. The beam can never be column less than 0 or more than the column length. So there is no splitters at the edge too. Yeah. They are really nice of giving the input so that you don't do out of bounds checking, I guess. Dot column to go up and this to go down. I mean, actually, you know, I mean, to go up we use like the caret, and to go down we use the V. Or we can also do like dot dot, like I don't know, dot dot more than, and dot, and like, you know, I don't know, like it's weird. This actually is a ligature. Look at this. It puts the dots at the middle for me. Interesting. The arrows. So like, so the arrow is pointing the direction of like ascension, right? I mean, we can do that. Why not? Let me just go here. I need to like figure out the priority. We need a 7.5 priority here. So we do like 4 like variable in so we have like end left arrow, long arrow, 0. No, not 0. That's going to be start, and then we have do, and then we have body, like this. Okay, so this like extra spaces is for the formatter, so that we know how to format the code. Day 7. Skipping unexpected left arrow here. Is that not the thing? No, I did it wrong. Hold on. 4. It's a little bit like difficult to see the things. This must be in quotes. Yeah, something like that maybe. Must implement the rule. Oh, there we go. So now it is parsed. And we have the formatter for it already. Nice. N.0 and I raw. So it's reversed. Okay, we can change the syntax easily. But we need to implement it with a macro. So we implement syntax for I in end to start. So this must be replaced with basically something like this. We say that let loop variable to be equal to, so we start at the end, right? So we start at the end, and then we say while loop variable is more than start, then we do a loop variable minus equal 1, right? And we say let I be equal to loop var, and then we do body over here. Something like that. Unexpected semicolon. Why is it unexpected? Hello? Which one? This semicolon is unexpected, but why? Oh, I just inequality here. There we go. So this works now, and we can write the code. So we just go from the bottom to the top. So this, by the way, so wait, no, I don't want this, actually. I want to decrease the loop variable before doing this. Like that. So we start actually at n-1, right? This is literally 0 to n reversed, which means that n is excluded, but 0 is included. That's what I want. What about words for I when 0 goes to 0? Well, I don't like the when. What I was thinking of is the down to, right? Like Pascal style for I in n down to 0. Like, that's what they do there, I think. We use the words. But I mean, eventually, this is not going to be the implementation, but the language is actually going to have the iterators like in Rust. So like 0 to m, this is an actual expression here, which should be an iterator, and we just iterate over it, right? But for now, because before I have it, I do this like hacky syntax. Just use n-1 if you want to start at n-1, right? Well, I mean, okay, you know what? Let's actually just do it like I want it, like in the end, right? I'm just going to say this dot rev, like or something, because I think that's how it's going to be in the end. You know? And then we do dot dot here, and then it's going to be still start and then end, right? So this is start dot dot end rev, right? We can literally just do this syntax. So right now this is like a special syntax, but we want this to be instead, like we want instead this to be an expression, and this should not be a keyword, but actually me calling the method here. My bot is not working. Let the following block of code execute as many times as it takes for variable x, which starts at n, reach 0 by a decrement of the variable. Yeah. Okay, so we just do this. And then inside here, I'm just going to say what? So we just go for j in 0 to m, right? So we are going to have the current row answers, right? And then I'm going to swap the next row before going to the previous row. We're going to say that next row answers is equal to current row answers, right? But we need to calculate the current row answer now, right? And then in the end, we are going to need to find the symbol s in our line, right? So we do for j in 0 to m. We say that if string, so like first line is map at index 0, right? So we do if string at first line like j is equal to s, then this is our answer, right? So we just say that answer is list. So we get the next row answers, and we get the at index j, and this is my answer, right? So we have dbg print answer here. Type check failed. Reference is not this and that. Next row answers. This is, yeah. J. Integer. Why is this not type checking? Need to improve the error messages still. So a reference is not a tuple of reference and an integer. Oh, because this needs to be like in parentheses before, because I'm dereferencing this. This gives me a reference to integer, but I need to dereference it. Yeah. The language has taken a lot of inspiration from Rust. Yeah. I don't have the borrow checker yet. So like this is a recent addition, and it's like I don't even have consistent APIs for references yet. Like for example, string at is a function that takes a string not by reference but by value, right? Like I need to like fix the inconsistencies here. And then the borrow checker is also planned, but for now, not there. It's a work in progress. Okay, so now we just need to calculate this thing, right? So we calculate the answer for the current cell. Current cell answer is like whatever, and then we do push back current row answers. Current cell answer. Right? Something like this. So right now, this is just going to print 0, of course, because I'm not calculating anything. So how do we calculate this? This is going to be really easy. We're just going to say that from here, the beam is going downwards, right? So we're going to check the string. So line below, I guess. Well, I mean, actually, we start at n-1, I think, right? Yeah, that makes it easier because, like, that otherwise we do get out of bounds because our inputs doesn't contain the splitters in the bottom. We can just start at the previous line and skip the checks. Sure. So line below is just map at I+1 then, right? And then we say that like character below is we need to get line below, and I need to get it at index j, right? So then if character below is equal to a splitter, then the beam is going to be like splitted, right? And we're just going to say that current cell answer is next row answers at j minus 1 plus I almost like want the syntax for this. Just do the indexing operator, but I don't have it. We can implement it, I guess. But we get j minus 1 and j plus 1 when we add these things together. Otherwise, we just say that current cell answer is equal to the answer below. So just list at next row answers j. The compiler is planned. Yeah. And the compiler is supposed to be a compile time like library, basically, or like the compiler is a library, basically, so that you can invoke it at compile time and like compile parts of the program to one thing and the other parts to the other thing. So I intend to use that feature for compiling the shaders for a game. But that's far in the future, probably. Relatively far. So, yeah. This still says 0. Oh, yeah, hold on. So in this case, we're actually splitting, right? So I need to also add 1 here. So it's 1 plus all of this, right? So we do a split plus the answer from the from that and the answer from that position. There you go. So this is still saying 0. Okay, beautiful. Let's do dbg printing here. Dbg, or let's just do print. So at to string I to string j is current cell answer string plus. Don't have string interpolation yet either. Wait, hold on, this doesn't even work. I never get into the loop. Wait, what? dbg print inside loop. Did I implement my syntax incorrectly? Hold on, what's wrong here? While loop variable is more than start. Oh, yes, because it's the loop is incorrect, right? We need to do from 0 to n minus 1 rev. There we go. That makes sense. Okay, the answer is 39. Is that correct? 21. It's not correct. So why is it not correct then? Did I misunderstand the the statement of the problem? So it's zeros at 13, 1 is 1, 1, 1, 1, 1, 1, 1, 1. Let's see. So for this line, right? So this over here is splitting ones, right? 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0. So there's just like a single thing that is missing here, which is seems like it's correct. Did I misunderstand the thing? How many times will the beam split? So it is actually merging. At this point, the two splitters create a total of only 3 Tycoon beams, right? So they are actually merging. Right? So I misunderstood. It maybe like what I did is the part 2. Am I right? Am I right that I just did the part 2? And this is part 1? At this point, the splitter creates a total of only 3. Yeah, there we go, right? So we split once here, and then this splits like twice more, but I treat this as like the 4 separate ones, but they want me to treat them as 3 separate ones. That makes sense. Only Kubi Souls part 2 because I did not read the thing. I was assuming that this is what they want because that makes sense to make a problem like that, you know? Okay, fine. How do we do the simpler solution? So we just so yeah, it actually is different, right? I need to like actually go from top to bottom and see if the beam is still there. Yeah, it's kind of like different. Completely. Let's do this. If part 2, then we do that, right? Or rather, this is if part 1, then we do one thing. Otherwise, this is part 2. So for part 1, we just go for I in 0 to n, and for j in 0 to m, and then we just keep our like answer. Right, and we also keep in which positions do we have the rows, the beams, right? So current beams is just list create, and then we do for I in 0 to m. We say that let list push back to current beams the string at, let's do first line. First line is going to be needed anyway, right? So first line at I, if this is equal to s, right? There we go. So we start with this thing, bbg print answer, and here we just so we start now at the first, and we go to n-1, right? No, we start at 0 still. Yeah, so we just say that so yeah, next beams is list create for j in 0 to m. We just push back next beams false, but then we say that if current beams at j so if we have the beam at the position j, then we look at the character and line below, right? So if we have the character below, then I need to say that next beams at, no, we don't have this. We do the list at next beams j-1. So this thing is equal to true. And then at j+1 is also equal to true. Otherwise, we just say that beam is going straight below us. So we say at j is true, like so. And over here we say just answer plus equal 1. So in this case, the actual splitting is happening, right? Is that it? So now we have 3. Wait, why is it 3 now? Oh my god. Oh, wait, it's because I never said that current beams is the next beams, right? So I need to say current beams is equal to next beams. There we go. Now the answer is 21. Okay, I see it now. And then will you do this for the actual input? Which is going to be pretty slow, it seems. Okay. Fatal error. What happened? Out of bounds. Wait, hold on. I have out of bounds. I have out of bounds when I'm doing this. Line below. Line below at J. Wait, what? But wait, hold on. What? That makes no sense. Oh, it's because, yeah, okay. It actually makes sense because there is probably an empty line there in the end, right? So to say like if this line is not empty, is not 0, then we push back like so. You know, something like this. Probably. String length line. One, 5, 2, 4. That's the right answer. Continue part 2. Am I right? The number of timelines active. So I think we actually like just do this and we just do part 2, right? Part 2. So this is 39. Wait, it says 40. The particle ends up on 40 different timelines. Oh, wait, because we have the timeline, like, we start the answer being 0, right? We start the answer being 0, because this is the amount of splits that we do, so we just say that answer... So this is the amount of splits, right? So the amount of splits plus 1 is the amount of timelines. That's it. There you go. So now we have 40, and then we do it for the actual input. Am I literally the only one who solved part 2 before part 1? Wait, this is not the right answer. My bad. Why is it not the right answer? Yeah, maybe it is. Wait, it's actually just overflowing, right? Because I need an int64 here. It's just overflow. I am not checking for overflows right now. It makes sense. We overflow because of the way this works. But it should fit into an int64, right? Which means that next row answers and this, so this should be like as int64. We're going to move that from my previous day, right? As int64. Let's do that. Current cell answer since 64. One as in 64. Wait, there is still somewhere. I don't report the errors properly. Value is in 64. Current cell answer is in 64. Next row answer in 64. Plus 1 as in 64. There we go. This plus in the end. You don't understand how long this took me? Alright. This is the right answer. Easy. Okay. Why did it take you this long, though? This is literally like... wait, what? I mean, it took you long because you're writing Bash. You should try a real language like Cast. You know? show me how you did it. This is just simple dynamic programming, right? So I calculate for every cell, if the beam starts in that cell and it goes straight down, how many splits will you have, right? So in order to calculate the answer for this cell, you only need to know the answer for the cells below, for the 3 cells below, right? So we calculate these answers from bottom to the top, and that's it. Does that make sense? I mean, you can read the source code also. A 7. That's how yours eventually worked as well. Yeah. Okay, what do I improve in the language? So right now, the most like pain thing I think is that my dereference operator is like requiring a lot of parentheses, and I don't like that. So in Rust, it would also require dereferencing operator, but in Rust we have syntax sugar, where we say like that like a at I is basically dereferencing to a dot like at I star, I guess. Star. Well, I mean, in my case, it's going to be the reference to this, right? So I can have this syntax for indexing. But I already use this indexing syntax for instantiating generics. Read chat. You tried lots of other things first, I see. I think there are lots of cool solutions for this one, actually. You can do top down faster. Top down. I mean, yeah, you can do top down too, because you just calculate for every position how many timelines have arrived into this position. That's technically the same thing, I guess, right? Yeah. Yeah. Could do it from top to bottom. Took me 3 hours to realize that a weird Pascal triangle looking thing. Read my chat. Will the compiler be implemented via macro, or rearrange AST to target, or via traits, straight to encode each type? I'm thinking of the second approach for my language. The way compiler is going to be implemented is that you have a function, you know, like you should be able to basically write a function. So this is like compiler to C code, right? Transpiler to C. What is the type of the transpiler, right? Transpile to C. So this is a thing that should be able to basically take your main function, right? So your main function is just unit into unit, I guess, or whatever, or into int32, which is like the exit code, right? And this will return the C code AST or whatever, or you just return the string directly, right? And then so that's the whole idea. You should be able to write this function. But in order to be able to write this function, you need to be able to inspect this function that you get as an argument, right? So you just have the inspection rules, like similar to how in Zig at compile time you can inspect the types and their structure. You should be able to also inspect the intermediate representation of the compiled function in this case, so that you can write a transpiler. So like you will already have all the type inference information available to you, all the symbols are resolved and everything. This is not just giving you the source code or ASTs even, right? It gives you the actual intermediate representation. That contains source? What do you mean? Actually, math is source. Well, sometimes just the source is not enough to do the compiler, because if you just take the source as the input to the compiler, then your compiler is going to do a lot of work that my compiler is already doing. like type inference, for example, right? When you just see in code like x plus y, how do you compile this? Because you need to know the types of x and y, right? So for different types, it should be compiled differently or whatever. But if you had a type C procedure, which had implementation of trait in code C, self-string, I mean, I guess sure. It's just like the trait is implemented. So yeah, sure. Transpile to C should have like the thing which is of type T. So this is a generic thing, you know, like, and you say like where T is transpilable to C, right? So T is implementing the transpile to C trait or whatever, something like this, I guess. So like it's not only working for functions because you need to transpile like other things too, potentially, right? Like you not only need to transpile the main function, but on everything else, yeah. Same. Anyway, that's the plan. But yeah. So what do I do now? I do want to change the syntax of something, like this indexing. Can I change the indexing? There's no such thing as the right way, only ways that work and better ways. Yeah. I mean, actually, right now, the most annoying part of the language is that if I look at the type of a list here, I look at the type of the map, right? Because this is a list of strings, but it's telling me the inner representation of what a list is. I'm implementing it using a trip currently. So, and I don't care about the inner representation. This should just say list of strings, right? So I should just add named types. I think you also got confused because I was doing the edgy recursion without recursive function things. Wait, is there even recursion here? I mean, no, you did it in a different way, I guess. Well, I mean, one way to do the dynamic programming is to do it with a lazy recursive thing, right? Like, for example, when you calculate the Fibonacci numbers, right? So if you have a Fibonacci number, then you say something like this, right? If n is less than 2, then it's 1. Otherwise, it's Fibonacci n minus 1 plus Fibonacci n minus 2, right? But this is obviously very slow, so you can... But you just add memoization to this function, and it's going to be linear again. Or you, instead of just writing a loop, you know? You do DFS with a stack. The Y Combinator. Is there a way you can make a calculator so you can play with the math in hand? Hello, March. Is there a way you can make a calculator so you can play with the math in your head? What do you mean? Like in my language? Can I make a calculator? I mean, I guess I can because I already have the interpreter and I have a REPL, so I can just do this and say 2 plus 2, and this is the math already, right? Or I don't know what your question was about. Yeah, let's add the named types. You mean when you're trying to figure something out, you will narrow the scope to understand something? I mean, yeah. You try to break a complex problem into simple problems. That's how generally problem solving works, I guess. I would rather add a built-in recur keyword to my language that can force users to have to use the Y Combinator. Wait, why did you say Y Combinator? What's Y Combinator? Why did you say Y Combinator? What is Y Combinator? An American technology company? Every function has a fixed point, in particular implementation of fix. Is that like the memoization or like... I mean, I've seen that before, but I don't know what it's used for. Like, what does it mean? It allows recursion. Oh, it's the thing that allows recursion if your language doesn't... So, like, because lambda calculus is a thing that does not have recursion. Lambda combinator, the Y combinator is the thing that enables the recursion, right? Hello, Giacomo Cavalieri. Hi. Shout. They spell it right? They did. Nice. Welcome, guys. You guys were doing the Gleam, right? Advent of Code. Gleamers in chat. Welcome, Gleamers. Yeah. So, yeah, I forgot to check the things. I actually solved the Advent of Code already. So I'm just going to be improving the language now. So I'm making my own programming language. And this is what the solution looks like. This is how the code is generally looking like right now. But isn't Lambda sole functionality? Yeah, I guess like we don't need the Y combinators for anything. You say you want a recur keyword to the language so that you force the users to have to use the Y combinator. What does that mean though? Recur keyword. Lambda calculus doesn't have binding, so it's impossible to write recursive functions in the traditional sense. Y combinator is able to use the fact that substitution can make copies of terms to allow to controllably call a function to be with itself as its argument. All right, let me like try to understand this. So we have the function that takes f, Y combinator. Hold on. So f is the function that is going to be called with itself as the argument, right? Lambda x, f x x. And we call that... So this is the function that we call with basically itself. That's why it's like repeated twice, right? So this is the function. And we call that with itself. Yeah. To control the allow function to be called with itself as its argument. I don't understand. Like, didn't you just say that you want in your language to have just the recurse keyword? So like when you write a Fibonacci number, Fibonacci, you would just say like recur, like n-1, plus recur n-2. Is that what you mean, right? So like if n is less than 2, then 1, otherwise this, right? So, and then recur is just a keyword which recurses into the current function. Yeah, we can do that easily, but there is no need for that. Like, but why do you do that instead of just like, how do you do mutual recursion then? I mean, I guess you can do mutual recursion with Y combinator, like, and similar stuff by being smart about it. But like, when you have two functions that must call into each other, how would you do that then? I feel like once I had an intuitive understanding of it, and it was similar to a pattern that people in imperative programming do sometimes. People in imperative programming actually do Y combinators sometimes. Doesn't have bindings means self-contained, which means it's everything is either a function or a function call. There's no variables. Yeah. So the only variables are basically the arguments of the functions. The way to do it with the gamma combinator would be y 5 Fibrec n. Yeah. Makes sense. Makes sense. Makes sense. Well, I mean, so right now I actually, because I'm not in the recursive scope, I cannot call the Fibonacci recursively. So in my language, you just need to go into the recursive scope, which is called a module. Modules are recursive, and then this can do it. Yeah. That who is this? DBG int who Fibonacci 10. Fibonacci 10 is 89, right? So yeah, this works. Why were we even talking about this? I don't know. I wanted to do this. I wanted to fix my my types to be named. So right now everything in the language is anonymous and like structurally typed basically. So because of that, the type of string of list length contains the structure of the list itself. Here. Cast. Let's see. So we just adding names to types. Don't know what I mean. This is the song that never ends. Yes, it goes on and on, my friend. Some people started singing. No, I don't know that. What is that? That's a song that I don't know, I guess. There's a Wikipedia page about it. Self-referential and infinitely iterative children's song. Yeah. That's how you teach a recursion to children. I was thinking about this yesterday, how much to show and how much to hide when making a type from existing types. Well, I mean, none of the existing languages are showing the internals, right? Like when you look in Rust, for example, or in any language, I mean, right? In OCaml or whatever, when you look at what like for example, right, option get is a function that takes a option and returns a, right? It does not say that option is either some or none here, right? Which is what I would say in my LSP right now. So I mean, it would say though this if so in OCaml we have the thing that is called OCaml polymorphic variance is what they called, right? So basically what I have right now is polymorphic variance, which is anonymous things, right? Let's try using that a little bit in the playground here. So we just say that type t is this, on or off. No? How do you do this? Syntax error. After unclosed opening, expecting a closing one. Do you need a vertical bar here still? Yeah. So type T is this, off or on. And then we say function f, which is like T into Boolean is a function on true, off, false, right? So I think this is the yeah. So like over here, this is inferred to be of type T. It does not say that this over here is type on or off. But if we say over here of 2, for example, this pattern matches the values of type question mark off. So this basically is like like any type which has at least the off 2 variant, right? If I say on to off to, yeah, this is still because I have asserted this, right? But if I do that, then you see, then it says that the function. Wait, actually, what if I do this? Yeah, if I don't assert that the type is t, then it says that this is a function that operates on type off or on, right? So this is closer to what I have right now. But then if we do the assertion, in this case, the type T is a named type, right? Because I have created it. And so this anonymous thing becomes a named thing. So yeah, we just literally do the same. So this was already implemented in my previous version. In my previous version, which how did that work? How did that work? I think I will just like look how I was doing that previously. So here's a type, and types should have names, but not all types have names. We have a thing that's called a new type, but what I want is not a new type. What I want is, so I think I was just storing this in the tuple types directly, right? This has a name, yeah. Would your language be a good tool for building game engines? That's what I intend to use it for myself. So hopefully, right? But it's not going to be actually a good thing. And like, in order for it to be a good tool for that, we need to have a compiler. We need to have like all of the low-level stuff also working, right? Right now I'm only focusing on the high-level parts of the language. But do you understand the thing? What thing? So tuple types have names, and I guess variant types also have names. That would make sense. Variant types also have names, yes. Wait, why is tuple? Oh, and this one is an optional name because we have both anonymous and named tuples. Bro, you need to activate Linux. Gzok. Hello. If you wanted to make a 3-element pair from a built-in 2-element pair type, you'd write it as data trio is pair. You might want to show the type as trio is equal to opaque, but in order to implement stuff on it, like first, is this, you still need to be known that trio is actually a pair, making it an ADT. For example, you would create one level of indirection so that both opaque and pair can be exposed at different levels. Yes. Yes. So you have types which are just type aliases, I guess. And you have types which are creating new types, which is different. But so but so you say this, right? So that you say that we have a type A and B pair is let's say just first A, second B, right? So this is the pair, and then you say that we have a type A, B, C triple, which is just a pair of A and B and C pair, right? So there's two ways to declare this type, either just directly like this or actually creating in the new type, which is creating a constructor for it, right? Like triple of this. This is a new type, and then this over here is a type alias. So in OCaml, when you create a type which is like the record type, this always creates a new type basically. But when you use an existing type, this creates a type alias by default, as I understand. So if we have a function f, which takes like int triple and returns something, is function x like so, what is it going to tell me? Well, it actually shows that it's a triple, even though it's an alias, right? So like sometimes you want to show the alias instead of the original name. Which, I mean, I'm not trolling you, just emulating Socrates. Types, why types? Like in Rust, if we have type foo is like option int 32, and we have function foo, which takes x of type foo. Then it has, then it still says that it's foo, right? It doesn't say that it's an option int 32. So yeah. But I think for now, like in my language, I will like this is a separate feature. I think this is just the display feature, because the name of this type is still option, right? Like if we go to the playground, for example, and we say function main, right? And we have a function. We have type foo is option in i32, right? And we say then print like if you take the type ID, right, std any type ID of foo, you are not going to see foo, right? You're going to wait. How do you print this thing? Like it's going to print the option, right? No. How do you print it? Type ID. It's like they have name or something, maybe. There's type name. Yeah, the type name. We want to print any type name, right? So this is going to be core option int32. So I think like for now we just show the actual type like this, and not like, and don't try to find the alias that I actually used in the scope, because I feel like that's a different feature, right? Because the actual type is this, and that's what we are going to show for now. Right, but right now I'm just saying that it's some or none. But if you only had one opaque type in the entire language, type A opaque is opaque of A, so that every other type can be flexibly made as opaque as you wanted. Either type trio is this, or type this is that. Here, opaque. I'm not sure what you mean, opaque. Opaque is just a new type, basically, right? Yeah, but why is it one thing? You should be able to create your own new types, right? Why should there be only one? Smaller core? Well, you still want to have the ADTs, right? Unless you get rid of ADTs completely, because that's how you get the new type. With a constructor opaque, just like you said. Okay, so when we have, let's just see. I will want this sustain to work, but I know why it's not. I'm confused by your messages, Dr. Professor. Okay, I want to have the type variant and type tuple to be things which have names, right? Name is name is name. So we need to have names. And type variant also has name. Is a name. And then we have and then we have name, which has parts. Which is a list of part names. Of name part list. So yeah, basically, what is a name, right? We want to say like std dot like option dot option int32. That's the name of the type, right? So this contains parts, and parts is like std. The next part is option. The next part is option, and the next part is instantiating that thing with int32. So part. So name part is either it's either a symbol, I think, or an instantiation with a value. Right? So when we instantiate generics, we treat types as values. So anything inside this, the generic argument is basically a value. And then all of these things are just symbols. Right? That's how I did it before. Let's take a look. Also, I had the optional names for these things. Name part. Oh wait, I had a file, a string, a symbol, instantiate, and impl-cast. Yeah, because actually, like, if we take a look at the if we take a look at like Rust, for example, then because that's what we want to be able to do, things similar to Rust. We want to be able to say, you know, over here, something like int32 as add int32 colon output, right? So in this case, this thing is a type which has a name, which is that. Wait, hold on. In this case, it's even that's my thing. It's my argument, which is a value. So I will want to print my values as this. But this value is a type, so this is the type. Okay, let's start with this symbols and instantiations, and then see if I actually need other things. Okay, I need to copy paste a little bit. There you go. No more red on screen. LSP support. Unbound value equals symbol. Symbol T. Okay, so now when I'm printing the type of variant, we have name and variance. So we actually don't print the thing. So we just print the name, right? We just print name, fmt name. Well, I mean, actually, names should be inferable. So name is not this. Name is not parts. No, that is not correct. Name is an inference variable. So inference variable of name shape, and name shape is this, right? So if we have inferred the name, then we know the parts, but if we have not inferred the name, then we don't. So, and then name part is also something that is potentially not inferred, right? I guess. No. No, name parts should be inferred, right? There's no way I can have not inferred name part. Conv ADT is not efficient for core data structures like you saw with linked lists. Not efficient for core data structures like you saw with linked list. What's not efficient? You want to do pattern matching without ADTs. Well, you can do dependent types instead. That would be more efficient potentially. Or my lists fast? What lists? Like right now I don't even right now I don't do linked lists. Right now am doing trips, which is why it's slower. I did not actually do the linked list yet. Maybe I should. Like at this point I should be able to do a linked list. I can try. But I want to add names. My lists are slow because they are trips right now and not lists. And also you don't even want linked lists. You want the arrays instead, right? For if you want speed. Like vectors. Right? For cache locality and stuff. Print name. Print name. Name unit. Function fmt var into name. Yes, and these function languages don't support them completely in the language. Like OCaml and Haskell. OCaml has arrays. OCaml has arrays. And Haskell has arrays. But it's mutable and stuff. Yes. Because you want mutability for speed. Do you want immutable and fast arrays that will require linear types? So linearity is basically mutability. It's just like writing code differently. So when you say that you have a like function like array set at, which takes array and index and like so array of a and index and value, and it returns a new array. If you want that to be fast, then you need this to be a linear function which like consumes this array and then returns a new array, which basically is mutability, right? But like written in functional style, I guess. So that's what you want, though. If you want the speed, if you want arrays that are fast, my trip is implemented completely via row types. Yeah. Well, I only use row types, row polymorphism right now for the variants. I don't use row polymorphism for tuples, right? But I like it should be the same. Yeah. But it's not like the trip itself is not a row, right? It's just, yeah. Yeah. It's just like that tuples are technically also should be like row types if you want anonymous tuples like with structural typing. Okay, print name. Name, var, unused variable. Okay, so we need to infer. Is there like a print var? Print var. Yes, there is print var. Recursive. The doctor professor. Are you a human? Or are you AI? The messages make no sense to me. What are you trying to do? How would I know? Yeah, that's a good question. How do you know that you are not AI? How do I know that I'm not AI? Do I not have print symbol? I probably have symbol print. Yeah, I have symbol print. And we have instantiation value. Then we're going to print. Wait, no. This is not the name shape. Hold on. This is incorrect. This is print name part. Name part. F print f fmt. So we do square brackets with the value inside, which is value. Is print value. Do you know what Douglas Adams means? Sounds like a name. If you want like to break me down this concept further, just give me the word. What concept? Do you know what 42 means? That's the meaning of life, as far as I know. And Douglas Adams is the author of the Hitchhiker's, right? It seems, which is where the 42 came from. Hitchhiker's Guide to the Galaxy, yeah. So this is print name part and print name shape. Name shape. So we just have parts there, right? So this would be list iterate parts. Using print name part fmt. No, that's not it. Function part. Like this, because we want to know if it's the first one. We actually want to iterate with index, I guess. We have index and this. Print name part. Print name part should basically have the like it should be like print name shape part, which like has a first, which is a boolean basically, you know, because we want to print the dot or not print the dot. Name shape part fmt, and then first is I is not equal to 0. This. First. So yeah, basically, I need that to print the dots in the name, right? So we print a part, and then if it's not first, then I need to like print the dot in between. So over here, before printing the symbol, I will actually print the dot, but I will not print the dot before instantiating the generics because that's unnecessary. So over here, just say that if not first, then print a dot, right? That's all. That is all. Okay, now here we have a type variant which has name and variance, which is unused. Sure. I'll keep that commented out for now. And tuples also have names. So, well, I mean, so tuples, I do want anonymous tuples, right? Which is why that was optional. What I want learn from that is how important a question is getting an answer. Yeah. So name is an optional name. Name is an optional name. But should the name be option here, or should the name be option in the name? Yeah, I need to like have the variant. Or do I make all my tuples named? That's another option, right? So like Zig recently removed the support for anonymous structs, right? So they are all named, but no, I'm pretty sure that I want to keep them unnamed. So like when I have a function which says like a function from A and B into whatever, then this over here should be printed still as A and B. I should not like name this type. This should be unnamed still. Which is why it's an optional here. Your questions make no sense. Dr. Professor's questions, I am assuming, right? Yeah, they do make not a lot of sense. But it's yeah, they're like citing something from the Hitchhikers of the Galaxy, maybe, or something. I'm not sure. I'm not sure. You think we should just time them out, or ban, for being weird? I don't know. But yeah, it's a little bit weird. Maybe you should stop being weird. How about that? Wow, I can just go. My bad. Well, I mean, I just like I don't know. Like it's supposed to be funny or something. Like I do remember that when I was watching the Hitchhikers of the Galaxy, it's just weird. Yes, too. But yeah. It's just like it. I do like being distracted on stream, but it seems like I don't know. It has been for too long, basically. You know, too long of the something that is irrelevant. So I usually prefer to actually try to stay on topic and just distract for a little moment. But it was a little bit too long. Okay. Call you transpile recursive types to native targets, individually boxing them. No. Not individually. That's why we call it, that's why right now I can do the recursive things only in a module. So when you when you have mutual recursion like this. Is my LSP breaking? Oh, I mean, it does make sense because it's not compiled right now. So I have like this module, right, which has a function f and function g, which is being called recursively, and it also has the depth here. Oh, you mean recursive types, not functions? I'll be honest, I have 4 screens on my desktop. I'm not always paying attention. Yeah. But you are trying to make a conversation, and trying to do the conversation without paying attention is weird, no? Recursive types, not functions. Yeah, recursive types. Yeah, maybe we will need to have some indirection. Like do some, yeah, like explicitly boxing things, like in Rust, will be required, I guess, in order to compile down to native code, or the compiler will have to do auto boxing. Yeah, I did not like think too much about that, like, but we will have, like, what I would like ideally is to have some sort of like, because like writing boxes in Rust, like writing down the boxes in Rust explicitly is sometimes annoying, right? So sometimes you want this to be done automatically, but sometimes it is really important, right? So, like, I want to support both use cases, where you just want to create the recursive type quickly and like have it auto-boxed, and then when you like care about stuff, then you should be able to explicitly say where the boxing is happening, you know? Probably with a compile time context. Which does something. Yeah. We'll think more about this kind of stuff when I'm actually doing native compilation. But I think for simplicity, for the first implementation of the native compilation, I will have the auto boxing just like OCaml. With so many, I want to support both answers. How soon will CAS be finished? That's why I'm saying, right? It will never be finished. But we are going to like, right now I'm going for the like, for some form of the language, right? But I'm trying to keep in mind that I will want to support other things. Then, like, I will need to think about low-level details, for sure. So many distraction questions from chat, cast will never be finished. Yeah, maybe I should just stop streaming and work on the cast off stream. Or maybe I should just not look in chat. Or maybe the chat is not always distracting, so it's fine. Or maybe we can just make progress some other time. This is inference. I just wanted to... Okay, let me just focus on this thing. We are doing the tuples, and tuples sometimes are named and sometimes are unnamed. So tuples should have an optional name, but whether it's named or not should be inferred. So unlike Rust, what we want is when we have a struct foo, for example, and we have field like this, right? So in Rust, when you say that foo is of type foo, is foo, where field is 1, right? That's how you do it in Rust. So what I want to do is I want to get rid of this useless repeatness here, which is similar to how Zig does it, where you just specify the structure, and we already know the type. It has been inferred, right? So yeah, that's why this thing should be inferred here. So name, I guess like it should be like optional name. I will just have a separate type for it then. And so we will have, similar to name, we will have an optional name. Optional name is just an option, a name shape option inference variable, right? That's the difference. And do I want to do the same for the variant types? I don't know, let's just do it as the previous implementation for now. All right, so let's do the inference. When I'm doing the inference of a tuple, when we have a name is a name A and we have a name is name B, so this means that these two names are the same, right? So I need to have a tuple where name is unite, unite. So this is optional. Unite optional name, name A, name B. And like that. If we have a variant, name is name A, name is name B, then it should be name, which is unite name, name A, name B. And when I'm inferring type of value shape, right? So if I have the value tuple, so value tuple should know about its type, basically, right? I think this should just know about its type. So if I have a value of like some oh, this is value, this is not variant, but variants also should know about their type. I know about the type of the type fields where this came from, but I don't know where this thing came from, right? So I just store the type here directly in the thing. Type. Just store the type here. Literally. Should the type be always the type tuple? I guess. And then value variant also, and value variant has actually the type in itself. Store the type, not the type variant. Why not type variant though? Why is this not type variant? Should this not be type variant? It should. Value tuple name. This. So in this case, name is potentially not inferred, right? But the structure can be inferred. Wait, this is value. This value. In the case of value, we just ignore the type. But when I'm printing the type, tuple name, in this case, yes, in this case I should print the name, but it's optional. So I only print the name if it is inferred, right? So I'm going to match name variable inference var inferred, right? If it is some name, then we print the name. But if it is some none or none, then we print the actual structure. So the outer sum is whether we have inferred it or not. So we have inferred that it doesn't have a name, or we don't know if it has a name yet. Then we print the actual structure. And I guess the same could be for the variance then. You know what? Let's actually go for the variance immediately. Like, so name, optional name. Oh my god. 1 second, I need a quick break. default. Now it works. But I didn't change anything. That makes no sense. 1, 2, 3. Like I just changed it back to default device and then back to like the actual microphone and it works. That's weird. First time that happened. Reminds me of the GIF where the guy is talking to a brick wall. Okay, and then over here we print optionally named empty name function into that. Right? So what is print optionally named? Print optionally named fmt. So this is formatter optional name unit function fmt name f. So I'm going to match name variable inferred. If it's some name, then we print name, and if it's none, then we just call function f, right? The value name has type name shape. Oh, because this is name shape. Print, yeah, in this case, we just print name shape. Okay. So inference, unite optional name, and over here, it's also unite optional name, right? How do we unite optional names? How do we unite optional names? Unite optional name is optional name inference. So we have function span, variable A, variable B. See, it's like OCaml, but instead of having print type for every type, you also have free type. Yeah. Well, I mean, technically in OCaml, the printing can be derived, right? I don't know if I like the deriving stuff in OCaml too much. I'm using the derivers to derive equality and ordering, and it's a little annoying. Because I can only either drive it for all the types or for none. I cannot select for which I actually implement it. Because of some stupid limitation. So I want unite option, unite name shape, right? So unite option is like something generic. Unite option is for all A. If we have a option, if we have a unite algorithm, then we know a option unite, right? There we go. So we have function unite value, then AB is match AB with some A and some B. Then we say unite value AB. If it is none and none, then return none. And if it is some and none, or none and some, then we fail. Wait, how do I fail here? I cannot fail here in this case. I think I need to do this like with exceptions actually. So like actually like right now my inference is a little bit weird because it assumes that I'm always creating the correct like inference result. So like for the things that are actually not unifying, like I'm returning the special error variant, right? This leads to some other bugs, but like for options that makes no sense. I think I will like let's just infer it to be some. I just say that there's an error. How about that? And then I will return some name then, some value, you know, some value will return some value, but I will want to do the error reporting, right? So this doesn't really, it's not really like the correct, but there is no correct answer here, so we just choose some, but I need to report it, which is this error span expect and unite. Wait, what? What just happened? My OBS was just disconnected for some reason. For no reason. We're still live though, right? So yeah, I don't know, like I will need to like pass here how to actually print A2 to do the error reporting properly, so we just do that. We just do that. Our camel format is ignored because there is a syntax error somewhere. Because this must be an arrow. Unite value, span AB. Expression has type A, but expected of type option. Yeah, so like we say some unite value. There we go. Nice. So unite option is there, and then what is unite name shape? And unite name shape is name shape unite, which is function span AB into. So we have parts is A, and we have parts is B, right? We only have parts there. So this is a list of name parts, right? So I need to unite lists, which means that they must be of the same length. There is a delay voice. 1, 2, 3. 1, 2, 3. My OBS seems like there is no delay. But you might need to refresh the page because I just was disconnected from Twitch and reconnected, maybe because of that. How does sprinkles come when you type? It's an extension called Power Mode. There is a delay of 0 seconds. All right. So you have like a list of the parts and list of these, right? So I need to do list. I can also do like unite list. Let's just inline it here. So it's going to be list zip, right? What does list zip do? If they have like, what if they have a different combine, right? Combine transforms a pair of lists into a list of pairs. Raise invalid argument if the two lists have different lengths. Not tail recursive. No, I don't want it to like raise invalid argument. I mean, yeah, I do want. Sure. Sure, let's do list zip. List zip AB into list map function AB into unite name part span AB parts is this, right? But this can fail, right? It's going to give me invalid argument. So we're going to try zipping with invalid argument. In that case, we are going to say, I mean, or I could just check the lengths first so that we don't catch the exception, but I don't think it matters. But in this case, we just, I mean, yeah. Yeah, I need to like select one of the names then in this case, right? If list length A is not equal to list length B, then we return parts is A. Otherwise, we return that. So, but in this case, I also want to do show the error, right? So we have the error cannot unite. I guess we just say that this is not equal to that, which is print name shape A and print name shape B. And I don't have print name shape. I do have print name shape, but I need to be. I need that to be exported. Print name is print name. Print optional name is print optional name, and print name shape is print name shape, and print name part is print name part. Is there no print optional name? I guess. Okay, so inference are value tuples. These just have the types is type A, and type is type B, which means that type is unite type A and type B. But this is type tuples. Unite type tuple, right? Unite type unite type shape. If we have tuples, this must be extracted, tuple A and tuple B. Then we do unite, we do t tuple t tuple t tuple t tuple t tuple unite type tuple span AB. There you go. And this is my actual thing, right? And unite type tuple is type tuple function span, like so. Right? We don't return tuple. And fail here is just going to be I slept 1.5 hours, you code for 2 hours, but that sleep was so good, it felt productive. Yeah. Happens sometimes. Have a nice short sleep. So in this case, I will just return this like as tuple A. Can I do that? I will just return tuple A, but I will need to give you the error. So I need to print type tuple now. A and print type tuple B. Which means that print type tuple print type tuple. It also needs to be extracted into its own in type shape and type variant too. I will want that too. Right. Yeah. Let's have print type tuple matter type tuple function fmt this is going to be a variant. Okay. And I will export that too, I suppose, with cache print type variant, print type variant. As tuple B. So I print tuple A and I print tuple B. And I return tuple A because we need to like return something here. Okay. Next what? Unite name part. Unite this. Print name shape A. But A is this. As name A. As name B. I print name A and I print name B. Unite name part is a thing that is not existing yet, right? Infer value shape, by the way, we have type tuple, which has name. So this is type tuple as type then, right? I don't care about the name here, I guess. So we have the value where we have the type. Okay, that makes sense. We have unite name part. Is that the only thing? Type of value shape. If I have a value tuple which has the type and this, then we return type tuple, which is the type. Right? That's all. So we don't really care about like the fields here because it's supposed to be already properly linked. Variant type variant. Yeah, and this is going to be inferred type span type variant type, right? Unite name shape. So unite name part. What is unite name part? Hello, DevNinja. Unite name part is name part unite. is function span
Hello Dev 9 inch nails ya.
AB into match AB with. So we have name part, which is either a symbol A and symbol B. Unite symbol. We don't have unite symbol, right? We don't. But we say when symbol equal AB, right? Only then they should be united. Symbol A. If it is a symbol and anything else, then we fail. Let fail be. But what do I return? I guess I just return A here or something. It's because I don't have this special error. Print name part A, print name part B. But I don't return error, I just return A in this case. This is not returning value. And then we have instantiation A and instantiation B. In this case, we say instantiation unite value AB. And we have instantiation with anything else, then we fail. It's calling free on stack pointer undefined behavior. Has to be. Yeah, you can only call free on the pointers which were allocated using alloc. Using malloc, right? Doesn't. So this stack pointers don't come from that. All right, substitute bindings is the next part. Let's see. We have substitute bindings. We have a tuple which has type. We now say type is substitute type. Substitute type. State type. Right? Okay. Next, over here we have a variant as a type. So this should be substitute variant. Substitute type variant. Variant type, substitute type. The expression has type tuple. Wait, what? Substitute type tuple. Why? Going to like extract substituting type shape, like, and to extract substitute type tuple. State type tuple returns type tuple, right? This is function. Type tuple. I just move this and return that. Right? Some record fields are undefined name. Yes, so that's going to be separate, but we have over here t, and then we say t tuple, substitute type tuple, state t, right? And this is going to be variant. Substitute type variant. State variance type variant type variant. That's going to be this. Substitute type variant state D, E. That stuff. Okay, so now we have names and in both of these, right? So we have a name and we have a name here. Name. But this does not work because names also should be substituted, right? So this should be substitute optional name state name. Do the advent of code in your language to find issues in the language is a cool use case. Yeah. But I mean, I think like I already made it to day 7, and like day 7 we just like we just solved it really quickly and easily today. So I mean, there are still missing parts, but in the language, but like the language is usable basically, right? So that's good. I did have to implement a couple things in like the first several days though. Before I could actually solve the advent of codes. But now I'm just implementing, I guess, optional features. Which is names currently. Substitute optional name. Okay, so substitute optional name state name, which is optional name, should give me back optional name. This should be substitute variable. Substitute variable state name dot var, right? So this is like var. No. Name. So we need to give it unite shape, should be inference unite optional name. It's not unite optional name. It's unite shape, which means that it's option unite option. It says unite option unite name shape, right? New not inferred is type new not inferred. New not inferred optional name. Get var is function name optional name var. And subshape. And subshape has a substitute. So this should be like substitute option with substitute name shape. Names like named parameters? No, like named types. So like right now, everything is anonymous. Like functions are anonymous, types are anonymous, everything is anonymous. So when you in the language you say something like type t is like, so like option is like some value or none, right? So I forget about the fact that we name it option. I just always say that it's either some or none, right? And when I say like foo, which is a thing with fields, we have like field x of type int, we forget about the name foo. We only have the x field here always shown. So it's like structural typing, which is like that. But you have recursive types. Yes, I have a recursive structural typing. So like, I mean, so like in TypeScript, it is also structural typing, right? But in TypeScript, your names are like aliases, I guess, and these names are like the names of the new types, more like, you know. It's so like if something has different name, then it's a different type, right? Which is not necessarily true in TypeScript. If we compare it to TypeScript, I guess. Is there a language spec? No. No. No, I'm just doing implementation first. I think like, so like now that the advent of code is usable, maybe like after the advent of code, I will spend a little bit more time to improve the website and like writing some more tutorials, how to like get started so that people can play with it. There is a little bit of the description. It's not really a spec though, right? But I do describe the stuff about my language here, what I want it to be. This is a little bit outdated, but we do have some description on the website. That's not a spec though, no. And it's outdated. But I mean, like the idea of what a language should be is still the same, I suppose. Learn. There's also like this comparing Cast and Rust, which also I think is not entirely like correct. I need to like revisit all of the things and update it and make sure that I have syntax highlighting for my code, not only for Rust code. Yeah, I have not spent. I spent a little bit of time writing about it, but I should spend more, I guess. You could make a tool that translates the syntax to BNF grammars. Yes. Not to BNF, to tree-sitter, I guess, is the most important, so that we can have syntax highlighting in Helix. Right? BNF is good for the spec. But it's not BNF. I don't think you can convert it to BNF because like, I mean, yeah. LC language websites have their BNF grammars on their home pages. Well, because they're implemented like that, I suppose, right? Does anyone actually look at the definition of the grammars though? I mean, if you want it for the spec, then the spec should not be BNF because that's not the implementation because of the extensibility. So it should not be BNF. If we talk about the spec, if we talk about just learning the language, then also it should not be BNF. Right? But like this, I can do something like this, but only for like the default syntax, right? But yeah, we can generate some images like this. I suppose. It's just like, I don't call this modifier invocation, right? You see, the thing is that in this language, when you have constructor, open parentheses, and then you have parameter list. So I have no, like, so for me, everything is an expression, right? So I will just say constructor, opening parentheses, and there can be anything here. So syntax-wise, it still can be anything. Here, anything can be here, anything can be here. I don't have like different types, right? For me, I will always have a single type, which is called expression. So everything is an expression. Although technically, like later, after the syntax is parsed, we also make like like technically like not everything can be present in all the places. For the parser though, everything is an expression, but for the compiler we actually split the expressions into like patterns and assignees and like expressions and place expressions and type expressions. What in other languages would be a parser error, in my language is okay, but a type error. So it's not like, it's not a type error, it will be like a compiler error, not a parser error. Because compiler is what gives meanings to the syntax, right? It's not the parser that gives the meanings. But in these other languages, you already have some meanings in the syntax, which is different, right? It's like, you know, in Lisp, everything is a list, right? It's very similar to that. But then not every like list is the correct program, right? You could show your grammar taking into account the compiler error phase then. Yeah, but like, yeah, maybe, I don't know, maybe we can think about that, but yeah. Or I guess like it's because, so like what I call the compiler and what I'm compiling into, I call it intermittent representation, but I think that's what usually actually called the AST. But the parser is only parsing the concrete syntax tree, right? So in the concrete syntax tree, everything is an expression, but in AST we actually differentiate. How I read those diagrams. Yeah. Anyway, let me see. So I was doing sub option and new not inferred. Let's do that. And sub option sub value state option is match option with none. And if it's some value, then we sub value state value sum, like that, right? So that should be very simple. This pattern should not be a constructor. The inspect type is optional name. Sub option, sub name shape. Well, because that's an optional name. Optional name is a variable. Wait, hold on. Hold on, sub shape. Name is optional name, sub shape. No, this is name shape option. Sub option, sub name shape. Sub value. So this should be like for all A, type A, sub value is, I mean, this should be inferable, right? So opt is not optional name. This should be like option A, right? Or like option something. Can you infer it then? This expression should not be constructor. The expected type is name shape option. Okay, there you go. It's this over here is incorrect. Why is that incorrect? And then we have and substitute name shape. State interpreter state. Name is name shape. Name shape. See that, and then there's also a new not inferred optional name. New not inferred. This must be having a span. Span is so this should return optional name. Variable is inference variable new not inferred span. That's what you want. Okay, so why are you complaining now? This should be subvar. Expression has type a option, but expression was expected of type optional name. Substitute type returns type unite type and type shape. Expression has type a option, but expression was expected of type optional name. Why does this has the type a option? Unite shape, inference unite option, unite name shape. I mean, let's just call it unite. No, yeah, we cannot. Option unite name shape. Let's see. Unite shape is a function. Let's see, does this work? No. It still is option because substitute shape is substitute option. This takes name shape, although it should be like more generic. Type A, substitute value is state interpreter state into A, right? This should be like A. But the OCaml does not like that. Right, is equal to function. Let's see, this should work for all A's. State interpreter state A state interpreter state A option. How did you end up solving day 7? You had to do some chores, so you missed it. Using dynamic programming for every cell, we calculated the answer if the beam started in that cell, basically, and then you just get the answer for the starting position. You meant part 2, right? Yeah, you did top-down dynamic programming. I did bottom-up instead, because I calculated for every cell like the amount of splits. It could be a bottom down though too, yeah. A top down. Doesn't matter. Bottom up is probably easier. I don't know. It depends like how you think, I guess. I think both of them are easier. But like usually, like I feel like bottom up is like the declarative way, and top down is like imperative way, I would say maybe. So like it depends on what type of thinking you usually do. Right? Because in top down you push and you calculate the things as is, like as you like, yeah, you like do it in a mutable way, and the bottom up is like the immutable way, you know. A ruby, nice. All right, I need to like figure out this type error, which is supposed to not be an error. New not inferred optional name. It's because subvar is the thing that works for values and shapes. Unite shape. Shape inference unite. Yes, that should work. Now we have subshape, which has state interpreter state. A value shape a value. Value shape value. It's like, but for this case, the value and the shape. Oh, I see. I understand now. So subshape. Yeah, this does not work. So sub option should give me not an option. This should be an A option inference of variable, I think, right? I didn't realize I could merge part 1 and part 2 until later, so what you're looking at is my cleanup version. So part 1 is just do BFS before refactor. Yeah, I guess like if, yeah, I guess if you do it the top down, then it's easily unifiable too. Yeah, I did them completely separately. That makes sense. This should be, hold on, substitute variable. Only I can go to the definition, stupid Okama. Like, why can I not go to the definition here? Why? Why not? Why not? Just go. I need, original value too, right? I need original value. So I need a option, another a option here, right? So this will be the option, and this will be like the original, you know? But we don't care about the original here, I suppose. I mean, in this case, it is basically original, but it doesn't matter. It's the same stuff. Wait, but oh, wait, so this should actually return a option inference var then still, right? Which means that in this case we do return, yeah, original, but in this case it is sum into inference Wait, should it be variable? Should not be variable, right? Substitute type. Substitute shape should be value shape value. Yeah. It should know about the values. Shit. So new inferred is what we need, right? So I need over here to say also new inferred. New inferred. And new inferred has the type what? Inferred span. So I will need the span. So next perform get context. Context is this. And span is context span. So over here I have a new inferred substitute value. New inferred. Let's have these named arguments. The new inferred will be like span into the actual value then, right? So this is not even inference variable, this is value. The dev dad. Hello. The dev dad. Thank you for the raid. Welcome. How are you guys doing? Did you solve the advent of code or were you doing something else? Of the concept of doing this in your own language? Yeah, so I already solved the advent of code day 7. Yes, I'm doing that in my own language, and now I'm just I solved it really quickly today. It seems like advent of code is, I don't know, it feels like it's easier this year than like previously. But yeah, I'm just now working on the language, improving it. So yeah, there are fewer puzzles, so I'm wondering if it's actually going to get like somewhat difficult at all, because it's already day 7 and it only will have 12 days this year instead of 25 days, right? So yeah, like but it's not, I mean today was the dynamic programming, which is like not like very basic, I guess, for the part 2. So yeah, but like until day 6 it was like very, very basic, I would say. What do you call your language? Is it literally my own language? No, it's called Cast. It's called Cast. We have a website if you want to take a look, although it's a little bit outdated. We have a playground where you can try this if it still works. Let me see if it still works. Let's see. Does it work? Run. Run, please. It doesn't run. I need to. Well, there is uncaught exception object. Yeah, like I need to fix my playground, but it like it's supposed to have. Wait, hold on. I have the LSP working in the playground, right? So why does it not run? So it is something that cannot. It was compiled, but it cannot run. Weird. What if I print hello world here? Run. Yeah, I don't know. Oh, wait, hold on. Hello world is printed. Something was weird about this program specifically. Input into string parse. That's weird. I think I will need to like figure that out. But yeah. Yeah, we have the language. It's called Cast. There is some information on the website. It might be a little bit outdated, but yeah. So I've been solving Advent of Code with it. We have LSP and stuff. And we have like a bunch of things. Yeah, I don't know. I don't know. This has no output in the example. Oh, maybe it just did. Wait, no. It was supposed to input, right? The that thing in the playground. It's supposed to input. Input is basically. Wait, input is a string? That's incorrect. Hold on. Maybe that's why. Let x be input. Input. Input is not a string. Why is input a string? Input is supposed to be a function that returns the string. std io input. This is not a string. The type inference is broken here or something. Because it's not that. Input is a function that returns a string. But if I do that, it doesn't work. Now, yeah, I don't know. Like, I'm breaking my type inference here somehow. Did you make it? Did I make what? The language? Yes, I did make the language. And I made it. And I made the Advent of Code solution too, I guess. That was your question. Okay, so right now I'm adding names to types because before today everything was anonymous. So I'm adding named types. This specific thing is the substitution. Substitution is something like when you see like type like t into t, for example, because we have a generic function which works for all t's, and then when we instantiate that function, we need to basically replace all t's with like the concrete type, like an integer into integer, right? We need to substitute every variable with the value that the variable has. That's what substitution is. Like, I just need to do substitution for names now too. All right. This needs an arrow. New inferred sub value. So this should return value. Original, and new inferred should return. New return should have a shape. So this should be shape option then, right? Shape option into V. A value takes shape, returns shape. Shape option. Okay, so now this compiles. All right, and now this code said that expression has type that, but what expected as something else, because for sub option, and to tell it how to do the new inferred, right? So sub value is sub name shape, but new inferred is what? New inferred is so it should be new inferred optional name, right? That's what we want. So we have new not inferred, and we need to have a new inferred optional name too. It's going to be new inferred value, span value, like that. Okay, this seems to compile, but substitute name shape is not correct right now, right? Because there actually needs to be some substitution. So name shape is the parts. So I need to substitute every part here. So this is going to be, this over here is parts. So we have parts is parts into list map, substitute name part, state, right? And substitute name part, state interpreter, state part, which is name part, is equal to what? So we're going to match part with, we have parts which are just symbols, in which case we just return the original one, and we have instantiation with value, in which case we say instantiation, and in this case we substitute value, state value like that, right? Okay, I think this is all done. Now we go to the interpreter. So the interpreter should know how to evaluate the tuple expressions. So we create a value tuple where type is the type. So this is type, shape, expect tuple, option get. So like this type is a type tuple. So yeah, we just store the type inside the tuple values now. Right? Now here, when we have an expression variant, it is very similar because we need to store the types. So type is going to be expect variant here. So we have expect tuple and we have expect variant, which will give me type variant option. The variant. So we have the variant where we just store the type directly there. Okay, next. So when I have a module, now that is interesting. Module should be same, I suppose. I need to know the type here. Expect tuple. Tuple is this and type. How do I get rid of option get here though? This is inferred opt. So this means that I need this to be already inferred to be a tuple. Not a type variable. Get rid of option get. I'll keep this as a to do for now. Use dot star. So we have a value type, in this case I guess can be ignored. If I have the expression field, we're trying to get the field of an object. We don't really care about the type of the tuple. I guess we don't really care about the types in the interpreter at all. Right? Evaluate type. But if I evaluate the type expression, which is a tuple, type, this is missing name. Yeah, so now over here, this is the interesting part, right? So when I create, so when I define a type expression tuple, so when I'm defining the tuple as a type, this is where I should give it a name, right? So when we see in code something like foo is type x is int32, this should be named foo automatically. This is the type expression, And I should give it the name. A foo. Which means that name. What should be name? That's the question. So name should kind of be... I mean, I can make this to be unnamed for now. For now, we are just going to make all the tuples unnamed. So that's the language still works. Right? Map, this is the list of variants. I ignore the name here and I create a new name in this place. I create a new name in this place. I feel like it should be like current name. It should be, so the current name should be what? Part of what? It's not in the interpreter, right? It should be syntactically known. Or should that name be available to me in the expression itself, right? Yeah. I feel like it should be just known to the expression. If we take a look at the old code, though, we have interpreter here, expression tuple, evaluate type. Let's create a non. So I only create a name when we have name. Variant name. We have a current name. Yes, I actually have a current name, which is part of the this is part of cast itself, which was both the compiler and interpreter. It's like outside here of the compiler and interpreter. But current name. So I was actually saying the name like during interpretation. So when I'm evaluating a tuple, the name is appending this thing here. This thing. Does that make sense to be an interpreter? It does a little bit. That's why I have the name part string, because we have fields of tuples also should be nameable, right? Yeah. That makes sense. Hello, Robert Pattinson. So I just say name is current name state then. You know, that's what I want. And like current name. So this is wait, is this optional name? No, this is name. This is not optional. But it should not be name, it should be name shape, I guess. Well, but this should return. But this should return. Hello, Nancodes. Welcome. Hi. How are you doing? If I do it name shape, then it should be like what I want is function that returns optional name. Right? Function state into, but this basically just creates a new inferred one, which is none right now. New inferred optional name. No type constructor. This is like types dot optional name, I suppose. Just got up and working on Nanify. Nice. Have you tried doing Advent of Code? Is Cast easy to learn? It's not the goal of the language to be easy to learn. But I think right now it is relatively easy to learn, yes. It should be pretty easy, yeah. But it's not the goal. Like, I will add more features to the language that will make it more difficult, I guess. Because it's supposed to be a powerful language, not an easy to learn language. What is it compared to other languages? Like, it's supposed to be like a powerful language, right? So the closest language that I guess we can think about is Rust, where like you have a lot of you have like the type system, which allows you to catch like a lot of bugs at compile time. But it makes it harder to learn because of the borrow checker, for example, right? I don't have the borrow checker yet, but it is planned. So, yeah. So if you learn Cast, Rust should be easier. Well, you cannot learn Cast yet because it's not done, right? It's a work in progress. So right now it's actually closer maybe to other languages. I don't know how to say this. Like syntactically, I'm not going for the Rust syntax. But yeah. Were you planning to learn Rust? So the idea is basically I want to make a language which allows me to write code easily. That does not necessarily mean the language that is easy to learn, right? I want the language that's easy to use. All right? So that. And I want, and like when we say easy to use, that like the most important thing is making it easy to maintain the program, because most of the programs that I care about are not the ones that I just write and throw it away, like the Advent of Code solutions, for example, right? So I want the language to catch as many bugs for me as possible, as early as possible, which is at compile time, right? Which is why borrow checker is a good thing, in my opinion. Yeah, I also have a couple improvements in mind. We'll see if that will work or not. Like Rust's borrow checker is sometimes a little bit too restrictive, and you have to like actually work around it, which makes it annoying. Yes. So yeah, I don't know. We'll see where we get. Right now, my ideas are like relatively rough. So yeah, we'll figure things out as we go. But ideally, it is also an easier to learn language than Rust, right? Because the borrow checker is not supposed to be in your way as much. Mm -hmm. New inferred optional name, span. What is span? I don't need the spans here. Let's span be span fake. Name. Only ask for several TV so you can't feel the wow man. But that means that I need to install an extension too. What's a good program to build for Rust? What's a good program built for Rust? What does that mean? Like, what's a good, like, test program that you would be building in Rust to learn Rust? Is that what you mean? I don't know, really. I would, I don't know. I don't know what's the good answer to that. Like, when I learn a new programming language, I'm just trying to make something that I've done before. So when I learn a new language, then I just write it, then I just try to figure out how to like interact with OpenGL and draw a triangle on the screen, I guess. But I don't know, if you have written a bot, maybe like writing a bot in Rust would make sense, like trying that. Right? Make 3D anime girl. That's another idea for a thing, yeah, to write, sure. But you can try making games. I don't know. You can try this to use some like game engine or something. Lack of games made with Rust invites to make a game using Rust. Yeah. There are a couple games written in Rust on Steam. A couple that I know of. There's probably more that I don't know of too. My game is written in Rust too. Hello, Penguin Operator. Use variable state. Yeah. So for now, just saying that the current name is none. That's what I'm going to do. That's good enough. All right, let's just keep working here. We have a native natives comparison function tuple. I need a type here. Type tuple. No, I need a name here. The name, which is in bindings. Wait. Dot new inferred optional name. None. Span. Is this not existing? What is this? Oh, because it's inside of the implementation. I need to like move this function somewhere else. This is not what I want. Value tuple type. I don't care about that. tuple make. All right. Okay, the interpreter is done, it seems, and now we have the compiler. So when we have the compiler, I'm just initializing the type inference here. So we have a tuple type, which has a name. But the name doesn't matter when we're trying to get a field of an object. We don't care about the name here. When we say that we have expression tuple, then the type of this expression is a tuple type, where name is supposed to be inferred. So we are actually going to say that name is the new not inferred. As much as I love Rust, I don't think it's as good fit for most kind of games. I don't know. I mean, I don't agree with that, but yeah, there is a lot of people who think Rust is bad for games, but I don't understand why. So it's because the people say that Rust is bad for games because Rust makes it hard to prototype. I guess because you're like changing your code all the time. I don't agree with that. I think that's false. I think that's a skill issue. The only problem with Rust is the compilation time. But in order to like be fluent in Rust and be able to prototype in it quickly, you need like experience. Yes, it takes time. It takes a lot of time, I would say. But yeah, compilation times suck, which is why I'm writing on Camel right now. Otherwise, I would be writing Rust. I'm writing a prototype right now, so I'm trying to do like rapid iteration here. But Rust compilation times in this project, when this project was written in Rust, it was like it was really bad. Like when I'm working on my game, my compilation times are not like what it was for my language. It was compiling for more than a minute every time I did the smallest change. So yeah, if the compilation time was actually quick, then Rust is good. Name. So name here is new not inferred. You know what? Let's see. Substitute bindings.impl. This thing. I want this to be instead. Optional name new inferred. There we go. I will make this module somewhere in cast types, I guess, somewhere here. Module named optional name. Type T is optional name. That's new inferred. It's not really the compilation time, but just the type of verification and compile time checking Rust does isn't that useful for games which are not that exact. What do you mean? I don't understand what that means. Yeah, I don't understand really. Yeah. I heard people saying that, but I don't understand what it means. I am making game. I don't have problem. Like that. Like what type of compile time checking is not useful? The fact that your game is not going to crash, is that not useful? Like I feel like that is useful. Why would you not want to make sure that your game doesn't crash, doesn't segfault, or whatever? Me 95% of the time, I don't understand what that means. Yeah. New inferred and new not inferred. I want to remove that. And I want to say optional name, new inferred. Over here I would say optional name, new not inferred. That's what I want. And I move that stuff here. New inferred and new not inferred. Let. Does that work? State is optional name, new inferred, none. Okay, back to the compiler. Or not. Syntax error. Rust is just safe enough to have manual management without the type of logic bugs that come with it. It's not actually doing as much as people think it is. I don't think... I wouldn't even like call Rust's memory management as manual. It is automatic. I don't call free manually, so it's not manual, right? The things are automatically dropped at the end of the scope instead of just sometime in the future, in GC language. So what's manual about that? Name. So when I have tuple, we have optional name, new, not inferred, span. Yes. So when I see in code that I am constructing a tuple, then we must infer the name for it. We must infer what type it is, right? But the structure of that type must match what we are creating. That's all. Manual from perspective of your executable managing it, not from a separate, not a separate runtime managing it. Okay. But it's not manual from the point of view of a programmer. From the point of view of the programmer, the fact that Rust doesn't have a separate runtime and that other languages have runtime, does it actually matter? Expression variant. Name is optional. Name, new, not inferred. All right, next. When we have a module. When we have a module, though, then I actually create the name here. This is where I create the name. Right? Name is optional name. So this must know the current name now. Optional name inferred. New inferred. Span, and this is going to be a state interpreter. Dot current name. I mean, let's just say current name here, that's all. It matters because other languages don't have move semantics. I don't know. Like Haskell, I mean, okay, languages don't have move semantics, but there are languages with linear typing that are still like garbage collected. Move semantics and the fact that memory is managed by your stuff is separate things, I think. I can have move semantics in my language here in the interpreter. So then the memory would be still managed by the runtime, right? But the semantics is still could be the same as we have in Rust. If you run Rust program through the MIRI, which is the interpreter, then the memory is managed. Well, I mean, I don't know. Maybe you still call to the allocator like of the C directly there, technically, even if you do it through MIRI. I'll take, says Raymarch. Well, I mean, on the other hand, Raymarch, have you created a game that is written in Rust? Have I created a game that's written in Rust? Not completely yet, right? Yeah. You know, and maybe my game is too small, and that's why I don't have problem with Rust or something, I don't know. Although the people who I've seen complaining about Rust with similar takes, they were creating games of similar size to my game. So I don't see why, like, how is that different? Right? Bevy abuses Rust so much it's barely recognizable as Rust. Might as well use a different language at that point. Bevy and Rust is two different things. I don't like Bevy. Yes. I agree. I would agree with that. My language is written in my own game engine. You can call it an engine. Bevy moves. Yeah. Also, they said rapid prototyping which is more relevant in quick design game than you finish several game jams in Rust. Yeah, like I've literally like what I've been done the most is I have only one game that is going to be published, going to be released on Steam, but I have made a lot of small game jam games in Rust, which is literally just pure prototyping. So like the fact that Rust is bad for prototyping, I completely don't agree with that because that's the main thing that I've been doing. People hate Bevy now. Well, not all people. There is a lot of people who love Bevy, but like. You see, there's a lot of issues there. So I mean, like in generally, basically, I guess like it's just like as Mouse Tail is saying. It's basically a different language, and it's not just a different language; it's a dynamically typed language because of the entity component system. Entity component system is is too dynamic, which basically feels like I'm writing a scripting language. Like Python without any types, so that I can have a lot of bugs that I can only catch at runtime and not at compile time. That's like in short why I don't like Bevy. But a game jam is not really prototyping, since you won't have time to throw out your concept and start again in a game jam. Rust's main weakness is large-scale refactoring is difficult. What? Rust's main weakness is large-scale refactoring is difficult? That's completely opposite. Rust's main strength is the easiness of the large-scale refactoring, in my opinion. Right? I think Lua is just superior than every language. Well, that's an opinion. Yeah. The fact that Rust checks for like the amount of compile time checks that Rust have compared to like other languages makes the refactoring a lot easier, so that you can just follow the type errors, and then once you are done, it's like, I mean, depends on the type of refactoring. So what's the type of refactoring then? I feel like what you're saying is because of your experience with Bevy. You have complained about Bevy, and I would say that this is true in Bevy. In Bevy, you cannot easily like refactor what components your entities have and stuff, because that stuff is not enforced at compile time. But that would be true about any other language, I guess. So yeah, because of that, like in general, in dynamically typed languages, or in a dynamic system like in ECS, which is what Bevy is based on, in any dynamically typed system, it is a lot easier to like not touch it if it works, because if you start refactoring, it's going to break. Yeah. Also, you tried writing your own engine in Rust, but had too many arc mutexes. Yeah. I do use arc mutexes, but I wouldn't say that it's a lot. And it's like not exposed, kind of, so it's, I don't know. I wouldn't say it's a lot for me. Initialize pattern. When I'm doing pattern matching against a tuple, I say that the name is not inferred. And the variant is the same. Do you all need to share stuff across threads a lot? Well, I mean, yeah, my engine is not even multi-threaded, so I am using not arc mutexes, I'm using RC ref cells instead, which is the same. RC ref cell is basically an arc mutex, just single-threaded. Nerdsil is also making a game in Rust, and never had a problem with too many mutexes. When is the demo coming out on Steam, Nerdsil? Did you already submit it for the review? Guys, relax, let's use AI. Nope. Type tuple, what is this? Core syntax, when I use dot star here. Type tuple, what is this? Value type of tuple. Name, I don't care about the name here. It will probably be in generally. Why don't you just upload the current build? You basically, you can upload it to Steam Nerdsil and make them review your binary, so that, but without publishing it, so that later you can like publish anytime you want, basically, is the way it works. Otherwise, you will have to wait, you know. I mean, it's not a very long wait, I guess. There's a review process for when you like when you want to make a public build. had the enemy AI run a separate thread for the game, which required Archmutex too many and didn't really work, though that was probably my own bad design rather than Rust's fault. Yeah, I don't know. I guess I didn't really do multi-threaded programming. All of my stuff is single-threaded because I was targeting the web mostly. So JavaScript is single-threaded anyway in the browser. So I didn't even try multi-threading my stuff. Recommend watching Chevy Ray, the creator of Ikenfell. What is Ikenfell? Is that like a game in Rust? Steam? Ikenfell? Ikenfell? Is that in Rust?
This change didn't happen until
Similar to Celeste. All right, I kind of want to get done soon, I think. Let's see, I have a couple more errors. Cast compiler. When I have a tuple... What is this? When I'm compiling this thing, I give it a tuple. Tuple is args. Name. No, type. I just give it the not inferred type here, I think, right? Type new not inferred. That's not a type. This is going to be type inferred. Type inferred, type tuple. Name is optional name. New not inferred. There's a lot of work here, but this is this over here. I have a to do here even. This is a custom syntax implementation. Type tuple. Name is this, and tuple is args into args is what? Args tuple map function field. So I should return type tuple field, which means as I mean, but I have it already. Will just be field into field dot type field, right? Like that. Expression type type, but expression was type tuple. Yeah. We just do that. Don't even need to be inferred. Type to type field. Unbound record type field, because this field is value tuple field. Optional name has type span. New not inferred without that. There we go. Okay, 3 more errors. Transpiler to a camel, which doesn't work. Let's ignore this. This is name. Is that all? Success. Okay, success. Do you think it's going to work first try? I mean, I didn't actually set the names anywhere, because all I did is is everything still unnamed, right? But it should at least like work as before, right? So my standard library should still be parsed and be available, right? Use std prelude. So we say like 1 and 2, and this is still the thing, right? But okay. So now the only thing that I need to do is then to set the current name, right? So I have the function current name over here, which says none, but it should not be always none. So instead of the state, which is the interpreter, I'm going to say that I have current name here. I have a current name here. Current name is, so this should just be like a list. Current name, we'll have it in the reversed order. Current name parts, this is a reversed order, so this is going to be name part rev, I think. Name part list, not rev. List. It's reversed because lists are faster to append to the beginning than to the end. So now when I create the new interpreter, I need to know where I'm at right now, right? So I need to give it the original like name. Right? So yeah. Name is what do I call it? Name? It's not the name of the interpreter, it's the name of the whatever. Maybe I say name parts. Then I'm gonna say current name rev is just name part, or try that. So when I say the default interpreters to still have a name. So when I create blank, this is the bootstrap. Blank. Name part. Default name part. This is the compiler. Interpreter without std interpreter. Oh, wait, hold on. Interpreter without std is the one that is used to create the std, which means that should have the name part, which is, I guess we will have the name part, which is string std then. So we should have a name part which is string of string. And to change these things to str s printf fm tier s Um, inference string A, string B, when A is B, string A, string fail, substitute bindings, string S, string S. Okay. The variant expression is expected to have type name part. There is no constructor colon within name part. Okay, yeah, because this is just a single part. Does cast solve cancellation safety? Not yet, not yet. I don't even have borrow checker yet, but it's going to. It's supposed to, yes. But you'll need to like write handlers for cancellation, I guess. Discuss interpreter.compiled. Okay, it's compiled to our own intermediate representation, which is a really high level, which is basically AST. Which is interpreted. Should make this a command response. Interpreter init. Interpreter with std. So in this case, interpreter with std is what I'm returning here. This is the interpreter that's going to be used for the compiler, which has a name part, which I actually pass as an argument here, right? Over here, this argument. Already to the blog. I think it's written somewhere on the website. No? And there's literally a section called compiled or interpreted. It's an interpreter with compiler implemented as a library. We still have compilation process, which is compiling to the intermediate representation. During that compilation, interpreting might still be triggered as like a comp time. And then we have intermediate representation as value, which so that you can run a function that converts it into the desired target. Like that's a section here already, right? Maybe it could be expanded or something. Init compiler interpreter. This should also be part name part. Compiler default name part. Init compiler interpreter. Evaluate end. Cast interpreter CLI. This is just the CLI. So I evaluate the AST here. When I evaluate this, I need to actually give it the name part. Eval option. Evaluate and do that. Name part. Name part. So when we have a REPL, for example, the name is going to be just REPL. So initialize compiler interpreter. REPL. You know? And evaluated is evaluate end match args path with this. In this case, we have a path Args path. Some. This is a Yuri, right? Args. Wait, args is the args. I see. So evaluate and has the args, and args has the path, which means that I already know the name of the thing. So never mind. We know, see, because I know the path that I'm trying to evaluate. We have the source, right? Or default Yuri std in. Let's name part be match path with some path, then something else, something else. So in this case, it's going to be a string std in, and in this case, it is string not else done. So this is supposed to be name part. So path here, this is a Yuri, right? So I need to say something like Yuri. Can I have like the last this file? No, like I want to have the last file fragment. Get the fragment component that's different. Like, so there's path, which is a string, but I want well, I guess I just take the path of this, and then it's probably something in the standard library. Sys file exists, file, maybe path, beep. Yeah, is there like file name? There's file name dot split a file name into directory name base file name. If name is a valid file name, then concat dir name and base name returns the file name, right? Is that what I want? The base name, right? It's not even base name. I want to get rid of the extension too here. So like if we are in the std, if we are in std.ks, and then it should be std, the current name, right? Probably. File name, chop extension, same as remove extension, but invalids if remove extension, right? Like this. That's what I want. Maybe. Cast compiler default. The interpreter. This is the transpiler. Default stir OCaml transpiler. OCaml transpiler. When we say run, we create the compiler. Compiler compile expression AST. Cast compiler. AST. We have the source. We have the source here. Maybe it should be the Yuri as like part of the name then, so that we can like refer to the file directly. Actually, should it? Should it be Yuri source path? Yuri mentioned. Why don't I just say the base name? Let's just say over here, Yuri path. So I will add over here Yuri of Yuri. Sounds like an exo stream, but it isn't. So it's just when I print, I maybe just when I print, I want to print that. Maybe we'll see. I can do that later though. Differently printing, but for now we're just going to extract when printing the name of the file, right? The name of the file, which is the base name with removed extension. My cursor is breaking sometimes. Yuri. That's the same thing. Why is this duplicated even? Why is this even duplicated? Print name shape part fmt first rule. There we go. That's all that I need. The inference. Yuri. Can I do structural calls or should I do Yuri equal AB? Yuri. All right, back to this place. So what is this? This is processing file. This is the LSP. So when LSP is trying to process a file, I need to say that this AST is being compiled in the Yuri source Yuri, right? There we go. And that thing is here. This is a unit. Okay, and then over here I have an interpreter. This is evaluating the interpreter. This is evaluating the workspace KS. So this is the file that is listing the roots inside. It still is a file that we evaluate, which means that this is going to be workspace KS. Yuri workspace.yuri, right? Like this. Okay, and then this says compiler is compiler default. This is the JavaScript. So in the JavaScript, when I cross JS async, this is run. So for running the JavaScript source code, I don't give it the name here. So we're just going to say that this is going to be string JS or something. Okay, success. I'm still not appending to the name, so like it's not going to work exactly yet. Let's go to hello world, restart the language server, and take a look at std. That's still is saying that this. So like I expected the std to have type std, but maybe I did not do that. Oh wait, hold on. Did I even do current name? No, current name is still none, right? But now we should return here that this is inferred to be new inferred parts. New inferred some parts. I think that's what I want. So we say that parts is state current part names rev into list rev into list map. I mean that's all, right? Current name parts rev. Yeah, like just like this. Okay, maybe this is going to do that. Yeah, there we go. So the type of this is just std. Why is there a dot in front of it though? Because that is weird. Why is there a dot in front of it? Let's see, print name part first. If not first, then this. Okay, what? First is I is equal to 0, not I is not equal to 0, right? That makes sense. Restart language server. So basically, std has its own type, which is called std, right? So now I cannot look into the inside, but we know that the type is this. So what if I say const foo is type x is int32, right? What is so foo is a type, right? When I say like foo is of type foo, right? X is 1 to 3 something something. Then this is going to say that type is hello, right? So this is incorrect, but the type is hello because the name of the current file is hello, right? I need to append to the names when I'm doing things, is what's missing here, right? So this is a named file, but the name is incorrect. Hello, hi. So the name should happen when I see a pattern in code like const foo is equal to, so over here the name should be basically hello.foo. That's the full name of this type, should be hello.foo.
Hello Nigel Ithro.
Hello Nigel. And then when we see something like const generic is generic t, and then we like do some other things inside, like type x is t, right? So then we say that generic, this is of type generic, in like string, right? Is x is high. So the type here should be saying generic string, obviously, because that's what we say here, right? It should be like hello.generic.string, .generic and string. So like we see this, so we append to the current name .generic, and then when I'm like inside of this body, when I'm compiling this, when I'm compiling this, the name should be, wait, hold on. The name. I mean, yeah, I created the new name, the new thing here when evaluating, so I know that t is string. Yeah. Yeah, let's see. Let's see this is happening in the interpreter. Why? Well, because when I'm doing instantiation of generics, I'm basically calling a function here, right? Colon typed function. This is my state, but I need to have a state with the argument. Argument is value. Yes. So we are instantiating using the value here. So I'm going to say that state is state with current name parts rev is state current name parts rev, but we are going to append to it the new name, right? And the new name is going to be instantiation of with argument. So if I do this right now, then we should see hello string, I think. Hello type string, there you go. So that works. And then I just need to say that I'm missing the dot generic part here, right? Obviously. So that happens when? That happens when I'm doing the assignment, right? I think so. When we do assignee, where is this function used? Only in one place, so I can do it directly here. So it's supposed to be when I'm doing a let. Well, I mean, in those cases, there's actually a const, so I'm evaluating that there too. Maybe it should be actually in the compiler. Core syntax const let. I think const let actually makes sense. So the value expression. I think that's also wrong. Maybe, I'm not sure. Yeah, why is it part of the interpreter state? That makes no sense. How did I do that before? I might have been doing this incorrectly previously. So when I have tuple field, it is in the compiler. Yeah, it is in the compiler. I'm changing the name. And in the and in the interpreter too. Because that's the interpreter used at compilation, right? So instantiation tuple, but then we just do it when we are compiling the assignment. So not in this place, not when I'm evaluating the assignment, when I'm compiling the assignment. Or a const. Makes sense. It is. What do I want? So wait, but why is the current name the name there? Hold on a second. What about the instantiation? Instantiation is also wrong. It should be template name. Yeah. Because current name is not the name of the which I inherited when I'm calling the function. That's right. So like the template is the value which has a name. So I instantiated that name with that argument. That makes sense. Okay, now I understand what I did wrong. Yes. So like when I instantiate the template that is defined, the generic that is defined in the standard library, I should not like have the name that starts with my current file, right? It should be because that generic is defined in the standard library. So what I need to do is go back to the interpreter, and when I say instantiation here, guys, I forgot I had big news. My pull request was accepted for the first time. No way. Can't wait for the pull shark badge. Yeah, so this means that current name is not that. Current name should be appended to the generic name. So like actually my values should have names, right? Or at least like, because we have a generic, so the value generic should have a name inside of it, right? Name is And it is not even optional, right? I mean, let's have it optional. Sure, I'm using optional names everywhere. Which probably also should be like part of the types, potentially. We'll see. So when I instantiating, I have the name here. Wait, why is this optional? This should be like already. This should be inferred, right? The name must be inferred at this point. To be something, right? I mean, yeah, it should. That generic name is name var inference var inferred option get. Like this can panic, but I think we'll see when I actually panic here. We'll see. Yeah, not even to do. I think this should not. So like this is a name shape option. Wait, but this is, if this is optional, then no. This should no. Let's have value generic name. This should just be this should just be name shape, I guess. Right? So we just have name parts, and then I just append list, not append. So I need to add the instantiation to the end, name parts, like so. But this is a ref, which means that I need to name parts, list ref, then add the instantiation to the beginning, because this is reversed. Maybe I should just not care about the reversion. This is a little bit annoying. What do you mean unbound constructor? You stupid like camel. Name part. Why can it not infer it? Okay, so when I have expression generic, this is evaluated. We just say that name is current name, right? But this one is optional. So current name should not be optional. Current or optional name is this, you know? But then we have a current name, because like name is actually always there, but this is just a helper. So current name is just going to give me name shape, I guess, which is going to be this original. So this is, yeah, that's not even needed. Let's function parts into parts. That's all. So this is state into some name, where name is current name state. This can be find lower. So current name for the tuple, this is going to be optional. And over here, it's also optional. And over here, it's also optional. Right? But in the initialization here, current name, current optional name. Sure. Okay. Okay. This makes sense. So now in the core syntax, I need to like change the name of the interpreter if needed, right? In certain places, and certain place is basically const let is one of them. So that's used in the const expression and in the use. It should be here only, I think. So we have a pattern. So I'm going to basically say that this is module C, which is weird. Can I say over here? Wait, hold on. What is module C? Compiler C. It has state, right? So can I do here struct include end? Is it module? Can I not extend the module like changing the thing? Or do I need to say struct end? So this needs state and compile. Compile is C compile. Does that work? And state is C state. But I could not include it for the first class stuff.
Hello, I borrow checked.
Hello, I borrow checked. Can I just call you by the way? When? When what? Right now. So state is... So state is going to be the state, right? But I'm going to actually say that... So I want to like change the interpreter current name here, right? I'm going to match pattern shape with, right? If my pattern is just a single binding, right? Pattern binding, then I will want to do something. In other cases, we just return the original state. But this over here is going to be the state with interpreter being C interpreter with current name parts ref is like something like that, right? Can I do that? Unbound value C interpreter, because it's C state interpreter. Okay, yeah. So this names should be like, I need to like add to the current state interpreter current this, right? And I need to add to the beginning the new thing, right? Which is Like it's supposed to be a symbol, right? Yeah, it's supposed to be a symbol, which is binding dot name. Name. There we go. Let's see if this works. Let's see if this works. Hello world. Restart language server. Place is not initialized. Could not find generic in the scope. Expected a type got error. Place is not initialized. The foo is not found. Inference error. Type T is not binding T. Type T is not binding T. In my trips. Type underscore is not equal to binding T. Which is very weird. This is supposed to be equal, right? Binding T is not equal to type T, but it's supposed to, like, that's actually false, right? That's what? Is that merging the names, right? Because that's the only thing that can fail, which was previously succeeding. I'm using OCaml modules. Yes. Why would I not use OCaml modules? I mean, maybe I should not use the first class modules. I don't really like how this looks. Yeah. This over here. This first class module. I don't use them a lot. I tried using them in this place. Maybe for the first time, and then I just kept it. Maybe I could have like replaced this with regular stuff instead. You find them to be awful, causing visibility problems and much more. Yeah. Oh, they are pretty bad. Yeah, I agree. Should change that. I'll try it now though. I'll just rewrite the language in itself, and then these things are going to be gone. Easy. So this is the unification, right? So this is inference implementation where I unite name part, I guess, is probably that, right? Name part, just to make sure that the error is name part, right? But it's not name part actually. Wait, this is not name part. Why not? Why not? Says type T is not equal to binding T. That makes no sense. Name shape. Name shape, name part. Not equal. Type check failed, which is different, right? Just say this over here, type shape. Type shape, this over here is type tuple. This is value shape. Name shape, name part, that's all right. But so it's supposed to be like a value shape. Value shape type T is not equal to binding T. Maybe it's because of this wait, hold on. Type T is not a binding T. Type T is not binding T. Over here. Type T is not binding T. Is it because when I substituted the bindings, I had the binding, but it was not substituted maybe? No, that makes no sense because binding T and type, like, if binding value shape. So it's a value that's a T that is we don't know if it's a type or not yet, right? Because it's a binding. Because this over here is just a binding. This T and this point is just a binding. It's weird. All right, if I don't finish this in 10 minutes, then I'm just going to end. It's been a little too long. Where's the issue? Like, these things, they're just supposed to be unified, right? Yeah. Why were they unified before and they are not unified now? Because the only thing that I added is names, right? The only things that I added is names. So why would this not be unifying? Does cast have first class scopes environment? Can I update the value of x in let x is 2? Let f be this by calling f from my own scope with a different value of x. Wait, what? What do you want again? Let x be 2, f is y instead of 2x into y. And you want to do by calling f from my own scope with a different value of x. What's your own scope? Some other scope? Can you update the value x by calling f from your own scope with a different value of x? What do you mean with a different value of x, though? So this closure is capturing x, which is capturing this value specifically, right? This is capturing a place, which is this place, which we initialized here because this is where the function was created. I don't even know what you mean. Like, I can call this function from a different scope, but like, so I can return this function, right? And this is my function. So now I'm in the other scope. So x doesn't exist here, right? But we can still call function f, and it will modify this variable. Yes. I mean, maybe it shouldn't, because like because this value is like dropped or whatever. But like before we have like the borrow checker and like that's this kind of stuff. But while it's garbage collected, yes, this is just going to be modified. So we can have a function, you know, print, which is just a function, which is dbg prints x, right? So we return print and f, and this is my functions, print and f, right? So we just call this function, and we'll just call print, right? And this is just going to, well, right now I have the type checking issue, but it's just going to print 1, 2, 3 here. I'm not sure. What do you have a specific example that you want? Unite name, unite optional name. How about I just return here variable is a, so like it always unites. Let's do that. Then we don't have any issues, right? So it is this that is not working. Okay, I see though. I understand actually. Yes, I actually understand what's happening. So we have the name, right? So what's the name of this type? What's the name of this type? What's the name of this type in the standard library? Trip, right? Where's the first error? Take a look at the first one. The first one is over here, right? So what's the type of this type, right? So this is a tuple which contains node left. Node left is having the type t lib trip. Well, first of all, there's the order which is incorrect, right? This should be like lib.trip.t with like argument t. So yeah, this is a little bit incorrect here. But the type of node left is trip t, right? But the type that I expect here is this instantiated with this t that we have, right? But we don't know that this is a type. So we have value which is binding. Okay, I think I understand though. It's kind of I think maybe I need to like to change the value inference. Unite value. Right? Like it means that this value is not just a binding, it's a type binding, right? So unite value shape is what I want over here. When I have two bindings, then it happens to be this, right? But binding should be able to, because types can be bindings. This should be so I should be able to unite a type and a binding, right? What's reference node? Reference of node pointer. Where? In the trip here? A reference is just a reference, right? Yeah, like getting like pointer, whatever, reference. This over here, yeah, this is, so node itself is a reference, right? So we need to dereference it and then do the dot. So like Rust is doing the automatic dereferencing and I don't yet. Is there any way I can call f with 1 to 3 and have it return 1 to 9 and not 1 to 5? Why would you do that? I don't understand what you're trying to do. Yeah, this is just the dereferencing. Yes. Caret is dereferencing. How do you define a pointer? By creating reference. Reference is how you create a reference. This at symbol, the ampersand, is for references. The caret is the opposite operator, which is a star in Rust and C. But I'm not sure if I like the stars. It could be like, I could see myself doing the zig notation, where we instead do dot star here, right? We'll see. You got star and add with different semantics. What? I don't have a star. Well, I mean, star just means multiplication. In C++, one is pointer, other is a reference. Yeah, because C++ is like a weird language. Or yeah. So like you define the type, the pointer type is star, is T star, right? Yeah. But when you create a reference, you do ampersand. And then you dereference by doing star pointer. So it's like 3 different versions. Yeah. Yeah, it's weird. It's a mess. I agree. Yes. Why are we trying to compare to C++? It's weird. Compare to Rust instead, if you want to compare. Okay, anyway, I just need to have the unite value shape. If I have a value which is binding a value which is type, which should be handled like before all of these, right? So if I have a value type A and a value binding B. So yeah, let's say type and binding B. So either this or value or like the other direction. Binding B and type T. In this case, it's going to be a type, right? So, but the bindings must be types, right? So I am saying that it's going to be a type. Wait, hold on. I'm unifying this. Binding. Does this even... I'm not sure if this can work. Well, so we kind of type binding the... Yeah. Into inferred type. Span. And I need to unite this thing. I need to unite this thing. So this is my shape. And I return shape. And I need to say that type expected. So I need to like type variable inference. This myself. Past inference base. What is inference in this scope? Yeah, this is the base. Inference variable infer as shape. Infer as this returns unit. I just need to give it how to unite, right? So we infer as unite type shape, right? Like this? No, infer as. This is value shape. Yeah, I need the type shape first. Yeah, this over here is the type shape. Type shape. Type shape is this. Well, I mean, yeah. We return value type where the type is this. It's not even type shape, right? It's just unite type. Type and T binding B new inferred type and like this. Is that correct? Maybe. Let's see. It seems like it works. Okay, now let's take a look at the hello world. Place is not initialized, generic is not found. Now that is wrong though, right? Because generic is definitely found. Foo is definitely exists in this scope, right? Cast examples, hello. So it says that it cannot find foo in this scope. In which scope? Why can it not find it? That's weird. I just want to know the relationship of x to f. Does it copy its value immediately? Does it hold a reference to it? Will it look for x in the scope only after it is called? It's supposed to capture it by reference, just like in Rust. Although in Rust it's weird. In Rust it's like sometimes by reference and sometimes by value, right? So it's not supposed, but yeah, so right now I'm capturing everything by reference. So I'm capturing the place where x lives, right? You know? So it holds a reference to it. But it's supposed to, but it is, no, no, it's not looking, I mean, yeah, it is looking for it in the scope after it's called, yes. But it's capturing the scope right now. But like right now, I'm just basically holding the reference to the entire scope in which the function was defined. But that's all obviously holding too much information, right? I should only hold the references to the actual variables that the function needs, right? Not the entire scope where the function was defined. So my functions right now are capturing too much, I guess. It's possible to replace the scope. It is capturing to something else. Well, there is no mechanism to do that. It's like so in Rust you can construct a closure and you want to replace the like the data. You want to support that somehow? Yeah, maybe. So basically a closure is a function plus the context that like plus the captured context, right? So you want to that context to be, yeah, I see, yeah. Yeah, you can also like do that literally through the context system though. Do not find foo in scope. While compiling plus expression, when initializing type expression. It's supposed to be in scope. That makes no sense. Oh, wait. Oh. Wait. Wait, what? No, this does not make sense. This does not make sense. What if I say let foo? Then foo is found. Which is weird. Type shape foo is not equal to that. Because this is not known at compile time, so this must be a const. So like I'm changing something, right? It is in my core syntax, I think, because I'm changing the interpreter to be the interpreter where the name is different, but I'm still having all of the other parts of the interpreter stage still there, right? So I still have the scope to be the same scope, right? The contexts are different also. But this is only state. Oh wait, I should wait, hold on. State is this. Hold on, const let. Value expression. Value expression. I think const let should use the, this is weird. Hello Yokogoma. Yeah, I'm kind of like modifying my state here, creating the new state. State, scope, mutable scope. Yeah, that's wrong. All right, I think I will fix this maybe off stream, and we will have the names next time. It's been a little too long. Time to go. Almost done though. Maybe I need like another like half an hour or something. Ferrari's trying a macro text editor.
Goes here.
Didn't like Vim. All right, see you guys next time. Bye.